Hello, and welcome. Thank you for being here with me tonight. We're about to take a very special journey together, through a moonlit garden, where the world grows quiet, and flowers open in darkness. For the next few hours, you can simply rest, and listen, as I share 100 gentle facts about night-blooming flowers, sparkling dewdrops, and the peaceful creatures that visit gardens after dark. This is a safe space, for sleep, for rest, for letting go of the day. There's nothing you need to do, nowhere you need to be, just here, now, in this moment. So settle in, close your eyes if you wish, and let the moonlit garden welcome you home. Let's begin. As twilight deepens and the last golden rays surrender to indigo shadows, something magical begins to unfold in gardens around the world. While most of us retreat indoors, drawing curtains against the gathering darkness, an entirely different realm awakens just beyond our windows. This is the hour when the moonlit garden reveals its secrets, when night-blooming flowers prepare for their brief, luminous performances, and when dewdrops begin their silent transformation from invisible vapor into crystalline jewels. Let me take you on a journey through this nocturnal wonderland, where each petal, each droplet, each whisper of fragrance tells a story written in starlight and shadow. Close your eyes for a moment and imagine stepping out into your garden as the first stars appear. The air has changed, it's cooler now, carrying different scents than it did at midday. The birdsong has faded, replaced by the chirping of crickets and the occasional call of a night bird. Your eyes, so accustomed to the bright world of day, begin to adjust, finding shapes and forms in what at first seemed like impenetrable darkness. This is where our story truly begins. Our journey starts with understanding why certain flowers wait for darkness, why they've chosen to bloom when most of the world sleeps. Night-blooming plants have evolved over millions of years to open their petals specifically after sunset, and this isn't mere coincidence or botanical whimsy. These remarkable plants have formed partnerships with creatures of the night, the moths, bats, and nocturnal beetles, that serve as their pollinators. Unlike their day-blooming cousins that attract bees and butterflies with bright colors visible across the spectrum, night bloomers have learned a different language entirely. They speak in powerful fragrances that can travel hundreds of feet on evening breezes, acting as invisible ribbons that guide their pollinators home through complete darkness. This evolutionary strategy has proven so successful that night-blooming species can be found on every continent except Antarctica, each one perfectly adapted to its local nocturnal pollinators. The relationship between these flowers and their nighttime visitors is one of nature's most elegant examples of coevolution. Over countless generations, the flowers have shaped themselves to match the needs and abilities of their pollinators, while the pollinators have developed specialized features to access the rewards these flowers offer. It's a partnership written in nectar and pollen, in wing beats and fragrance molecules, in moonlight and shadow. As you wander through a moonlit garden in late spring or summer, you might encounter the legendary night-blooming cereus, sometimes called the Queen of the Night. This cactus flower holds a spectacular secret. Each bloom opens for just one single night before withering away with the dawn. Imagine the patience required, watching the large, magnificent buds form over weeks, waiting for that one perfect evening when temperatures and humidity align. The anticipation builds as you check the buds each evening, looking for signs that tonight might be the night. Then, usually between 8 and 10 o'clock, the petals begin their slow unfurling, a process you can actually watch if you're fortunate enough to be present. The flower opens gradually over the course of 2 to 3 hours, and witnessing this event feels almost ceremonial. The tightly wound petals begin to loosen, spiraling outward in a graceful dance that seems choreographed by invisible hands. As each layer unfolds, the flower releases its fragrance in waves, growing stronger and more complex with each passing minute. The scent is so intensely sweet and layered that people have compared it to vanilla mixed with exotic spices and tropical fruits, with undertones of jasmine and hints of something wild and indefinable. Some describe it as intoxicating, others as transcendent. By morning, this queen abdicates her throne, the petals growing limp and translucent, never to open again. This ephemeral nature makes witnessing a night blooming serious and experience gardeners remember for a lifetime, often inviting friends and family over for serious parties when they sense a bloom is imminent. But the Sirius isn't alone in its moonlight vigil. As you continue your nocturnal wandering, perhaps following a stone path that appears silver in the lunar glow, you might notice pale, trumpet-shaped flowers glowing almost phosphorescently in the darkness. Many night-blooming flowers are white or very pale in color, and this adaptation serves a crucial purpose beyond simple beauty. White petals reflect whatever light is available, whether from the moon, stars, or even distant street lamps, making them visible beacons for nocturnal pollinators navigating through darkness. This is why moon gardens, designed specifically for nighttime enjoyment, feature predominantly white and silver flowers. Plants like moonflower, angel's trumpet, and white nicotiana create an almost ethereal glow, transforming ordinary garden spaces into dreamlike sanctuaries where the boundaries between earth and sky seem to dissolve. Garden designers who specialize in moon gardens understand that they are not just planting flowers, they're creating luminous sculptures that come alive in darkness. They carefully position these pale blooms to catch moonlight from different angles, creating layers of soft radiance throughout the space. Silver-leafed plants like lamb's ear and dusty miller add to this effect, their foliage shimmering like mercury in the night. Walking through such a garden feels like moving through a living constellation, each white bloom a star brought down to earth. As the night deepens and you pause beside a bed of evening primrose, you witness another of the garden's nocturnal miracles. The evening primrose doesn't just open at night, it opens with such speed that the process is visible to the naked eye, almost startling in its urgency. Within just a few minutes, the tightly closed buds pop open with an audible sound, like tiny fireworks celebrating the arrival of darkness. If you're standing close enough in the quiet of evening, you can actually hear a soft popping or clicking as each flower springs open. This rapid opening serves an important function. It ensures the flowers are fully accessible during the peak activity hours of their sphinx moth pollinators, maximizing the chances of pollination during the relatively brief window when both flower and pollinator are active. The bright yellow blooms seem to capture and hold whatever moonlight touches them, creating pools of gentle radiance along garden pathways. In a moon garden dominated by whites and silvers, these yellow primrose flowers offer a different kind of magic. They glow with a warmth that seems almost impossible given the cool tones of night. Their color takes on a quality that never appears in daylight, a soft luminescence that draws the eye and seems to pulse gently in peripheral vision. Now, let us turn our attention to another phenomenon that makes moonlit gardens so enchanting, the formation of dew. As you brush past leaves and grass blades in the darkness, you feel the coolness of moisture against your skin, dampening your shoes and the hem of your clothing. This isn't rain, nor is it water rising from the soil through some mysterious capillary action. Dew forms through a process called condensation, and it happens most abundantly on clear, calm nights like the one surrounding you now. Here's the beautiful science behind it. As the sun sets, solid surfaces like leaves, petals, and grass blades begin to radiate away the heat they absorb during the day. They cool down faster than the surrounding air, becoming like cold glass on a warm day. When their surface temperature drops below what's called the dew point, the temperature at which air becomes saturated with moisture and can no longer hold water in vapor form, the water vapor in the air transforms directly into liquid droplets. Each leaf becomes a collection point for thousands of microscopic water beads that gradually merge into the larger drops we recognize as dew. It's the same process that creates condensation on a cold drink in summer, but happening across every exposed surface in the garden simultaneously. What makes this process even more fascinating is that dew doesn't form equally everywhere in your garden. If you observe carefully during your moonlit wandering, you'll notice that some plants are absolutely drenched, their leaves bowed under the weight of accumulated moisture, while others nearby remain relatively dry. This happens because different surfaces cool at different rates, creating microclimates throughout your garden. Plants with broad, flat leaves that are exposed to the open sky radiate heat more efficiently and thus collect more dew. Their leaves act like cooling plates, reaching the dew point earlier and staying cooler longer. Meanwhile, plants sheltered under tree canopies or near walls that retain and re-radiate heat may stay above the dew point and remain dry. The type of surface also matters. Fuzzy or hairy leaves often collect more dew than smooth, waxy ones because they provide more surface area and nucleation points for water droplets to form. The amount of dew that forms on a single night can be surprisingly substantial. In optimal conditions, the equivalent of light rainfall, sometimes as much as 0.5 millimeter of water coating every exposed surface. In arid regions, this nightly dew can be a crucial water source for both plants and small creatures, sustaining life in ways that remain invisible to casual observers. For night-blooming flowers, dew plays a special role beyond simple hydration. Those dewdrops clinging to white petals in the moonlight create countless tiny prisms and mirrors, amplifying the flower's visibility in ways that seem almost intentional. Each droplet catches and reflects available light, making the blooms shimmer and sparkle like they've been dusted with diamond powder. This enhanced visibility serves the flower's ultimate purpose, attracting pollinators. A dew-covered white blossom in moonlight becomes exponentially more noticeable to a moth flying overhead, transforming each flower into a lighthouse beacon guiding the way. The dewdrops don't just reflect light, they refract it, breaking it into subtle spectrums that create an almost magical quality around each bloom. As you kneel down to examine a particularly dew-laden bloom more closely, perhaps you're drawn to the moonflower vine, a cousin to the common morning glory but with flowers that can span 6 inches across, as large as a salad plate. The moonflower demonstrates another remarkable adaptation. Its blooms are not only white and fragrant but also structured in a way that makes them particularly efficient at collecting and displaying dew. The broad, slightly cupped petals create perfect platforms for dewdrop accumulation, and as the droplets catch moonlight, they create an illusion of the flowers glowing from within, as if lit by some internal luminescence. The moonflower opens its blooms in the late afternoon or early evening and keeps them open throughout the night, maintaining a vigil that can last 12 hours or more. Unlike its morning glory relatives that close up the moment sunlight touches them, as if sunbeams physically push the petals shut, the moonflower maintains its display until the morning sun grows strong, giving gardeners a window of several hours after sunrise to enjoy these nocturnal beauties in daylight. This extended blooming period means moonflowers serve 2 shifts of pollinators, the night moths that are their primary partners, and early morning bees that sometimes visit before the flowers finally close. The interplay between night bloomers and their pollinators reveals itself in countless subtle ways as you continue your moonlit wandering. Consider the hawk moth, one of the most important nocturnal pollinators in many regions. These remarkable creatures hover like hummingbirds in front of flowers, their wings beating so rapidly they create a soft humming sound in the night air. They use their extraordinarily long tongues, sometimes extending 6 inches or more, to reach nectar deep within tubular blossoms. Watching a hawk moth feed is mesmerizing. It approaches each flower with precision, unfurls its improbably long proboscis, and inserts it into the flower's throat with the skill of a surgeon. The flowers these moths prefer have evolved to accommodate them perfectly, with trumpet or tube shapes that exclude other visitors and reserve the nectar specifically for moths with the right equipment. Some night-blooming tobacco plants produce flowers with nectar tubes so deep that only specific moth species can access them, creating an exclusive partnership refined over countless generations. The moth gets a rich meal, the flower gets pollinated by a visitor that will likely travel to other flowers of the same species, ensuring genetic diversity. It's a transaction millions of years in the making, played out fresh each night. This brings us full circle in our first exploration of the moonlit garden. Everything here is connected through invisible threads of evolution, adaptation, and mutual benefit. The flowers bloom at night because moths fly at night. The moths fly at night because that's when these flowers bloom and when competition from other pollinators is minimal. The dewdrops form because surfaces cool beneath the vast openness of the night sky, radiating their heat into space. And those same dewdrops enhance the flowers' moonlit visibility, improving their chances of attracting the very moths they depend upon for reproduction. It's an intricate dance choreographed over millions of years, performed fresh each night in gardens around the world. Each element supports the others. Fragrance guides pollinators when sight fails in darkness, white petals maximize visibility in low light, dewdrops amplify that visibility further, and the timing of flower openings matches precisely with pollinator activity patterns. Nothing here is random, everything serves a purpose refined by endless generations of trial and error. As this first segment of our journey comes to a close, take a moment to imagine yourself standing in such a garden right now. Feel the coolness of dew-dampened air against your skin, raising goosebumps on your arms. Breathe in the heady, complex fragrances of night-blooming flowers releasing their perfumes into the darkness: jasmine, honeysuckle, nicotiana, each adding its own notes to the nocturnal symphony. Watch the pale blossoms seeming to float in pools of shadow, glowing softly in whatever light the moon provides. Listen to the almost imperceptible sound of flowers opening, of moth wings beating, of dewdrops forming and occasionally falling with the softest of taps onto the leaves below. The moonlit garden is always there, waiting just beyond the reach of our porch lights and street lamps, existing in a realm we too often overlook. It asks only that we step into the gentle darkness and open ourselves to its quiet wonders. In our next wandering, we'll explore more deeply the specific flowers that make these nighttime gardens so magical, the creatures that depend upon them, and the ways that dew transforms from simple water into nature's jewelry, adorning every surface it touches. For now, rest in the knowledge that while you sleep, gardens everywhere are alive with purposeful activity, ancient partnerships, and breathtaking beauty that asks nothing more than to be witnessed by those patient enough to wait for moonrise. Welcome back to our moonlit wandering, where the garden continues to reveal its nocturnal mysteries. As we venture deeper into the night, the moon has climbed higher in the sky, casting longer, more dramatic shadows across paths and flower beds. The dew has grown heavier, and the air carries that particular coolness that only comes in the hours after midnight. This is when the garden's secrets become even more profound, when we discover the intricate details that make nighttime blooming not just a survival strategy, but an art form perfected by nature. Let us begin this segment by exploring one of the garden's most enchanting night bloomers, the angel's trumpet, known botanically as brugmansia. These magnificent plants produce enormous, pendulous flowers that can measure up to 20 inches in length, nearly 2 feet of floral splendor hanging like elegant bells from sturdy branches. What makes these blooms particularly remarkable is the way their fragrance intensifies dramatically after dark, becoming almost overwhelming in its sweetness and complexity. During daylight hours, you might walk past an angel's trumpet and notice only a faint, pleasant scent. But as evening arrives, these flowers undergo a dramatic transformation. Their scent production increases by as much as 500%, releasing waves of perfume so powerful they can fill an entire garden and even drift into nearby homes through open windows. This isn't merely a random intensification, it's a precisely timed response to the presence of their primary pollinators. The sphinx moths that pollinate angel's trumpet are most active during the deepest hours of night, and the flowers have calibrated their fragrance release to match these peak activity times. The scent carries compounds that are particularly attractive to moths, including molecules that mimic the pheromones moths use to communicate with each other. In essence, the flowers are speaking the moth's own language, sending out signals that say, "Here, right here, this is what you're searching for." Stand near an angel's trumpet on a warm summer night, and you might see multiple moths hovering around a single bloom, drawn from distances of up to a quarter-mile away by this olfactory beacon. As you move through the garden, perhaps following the silvery gleam of a gravel path, you encounter another fascinating resident of the night garden, clocs, which bear the scientific name Mirabilis jalapa. The common name tells you almost everything you need to know about these charming flowers. They open at approximately 4 o'clock in the afternoon and remain open throughout the night. But here's where these plants reveal their true wonder: a single 4 o'clock plant can produce flowers of multiple colors simultaneously. You might find pink, yellow, white, and magenta blooms all appearing on the same plant, sometimes even on the same branch. Even more remarkably, individual flowers can display stripes or sectors of different colors, creating patterns that seem almost painted by hand. This unusual characteristic occurs because of genetic instability in the pigment-producing cells, causing different parts of the plant to express different color genes. What's particularly magical about observing 4 o'clocks in moonlight is how these different colors appear to glow with varying intensities. The white blooms shine brightest, while the deeper colors create pools of shadow and mystery. And here's another secret these flowers hold: they're incredibly sensitive to temperature and light levels. 4 o'clocks close when temperatures rise or when bright light strikes them, which is why they remain tightly shut during the heat of the day. But as temperatures cool and darkness falls, they respond by opening wide, their petals unfurling in that liminal time between afternoon and evening. On cloudy days, they might open earlier; on particularly hot evenings, they might delay their opening. They're constantly reading environmental cues, making micro-adjustments to optimize their chances of pollination. Now let's turn our attention to a phenomenon that makes the moonlit garden particularly magical for those who know where to look: the presence of guttation droplets, often mistaken for dew but formed through an entirely different process. While dew condenses from air moisture onto cool surfaces, guttation occurs when plants actively push water out through specialized pores at the edges and tips of their leaves. Walk through a garden in the pre-dawn hours, and you might notice perfect, spherical droplets balanced on leaf margins and tips, looking like liquid pearls carefully placed by invisible hands. These droplets form when soil moisture is high and humidity prevents normal water evaporation through the leaves. Unable to release water through their usual transpiration process, plants instead force it out through structures called hydrothodes, specialized openings that act like pressure relief valves. The water emerges carrying dissolved minerals and sugars from within the plant, making guttation droplets slightly sticky and more substantial than pure dew. In moonlight, these droplets create an entirely different visual effect than dew. Because they tend to be larger and more perfectly spherical, they act like tiny magnifying glasses, each one focusing moonlight into a bright point. Some plants are particularly prone to guttation: strawberries, grasses, and many tropical plants regularly display these jewel-like droplets. The presence of guttation tells you something about the garden's health. It indicates good soil moisture and active plant metabolism, signs that your garden is thriving even while you sleep. As we venture near a wall or fence in the garden, we might encounter one of the most intoxicating of all night bloomers, night-blooming jasmine, or Cestrum nocturnum. Despite its common name, this plant isn't a true jasmine at all, but it produces a fragrance that many consider even more potent and beautiful than its namesake. The small, tubular, greenish-white flowers are almost inconspicuous in appearance. You could walk past them in daylight and barely notice they exist. But this humble appearance belies their extraordinary power. As darkness falls, night-blooming jasmine releases one of the most powerful and far-reaching fragrances in the plant kingdom, a scent so intense that a single plant can perfume an area the size of a football field. The fragrance has been described as sweet, rich, and almost narcotic in its intensity, with layers that reveal themselves over time, initial notes of honey and orange blossom giving way to deeper, more complex undertones. What's particularly fascinating about night-blooming jasmine is that its fragrance production follows a remarkably precise schedule. The scent begins to intensify around sunset, reaches peak intensity between 10 p.m. and 2 a.m., and then gradually diminishes as dawn approaches. This timing corresponds exactly with the activity patterns of the night-flying moths that pollinate it. The plant is essentially ringing a dinner bell, announcing to every moth within range that nectar is available. In some cultures, night-blooming jasmine is planted near bedroom windows so the fragrance can drift indoors, though this practice has fallen out of favor in some regions because the scent can be so overpowering it actually disrupts sleep, filling dreams with its presence. Moving deeper into our exploration, let's consider the remarkable adaptations of the moonflower's leaves, not just its blooms. Moonflower vines produce leaves that are specially adapted to maximize dew collection, and they do this through a feature called a drip tip, an elongated, pointed leaf tip that channels water downward. Throughout the night, as dew accumulates on the broad leaf surface, it gradually flows toward these drip tips, where it collects and eventually falls in concentrated droplets. This adaptation serves multiple purposes. It prevents water from pooling on leaf surfaces where it might encourage fungal growth, it directs precious water toward the plant's roots, and it creates a regular, rhythmic dripping sound in the silent garden, nature's own percussion section. If you sit quietly in a moonlit garden and listen carefully, you can hear this symphony of falling dewdrops, each leaf contributing its own note to the nocturnal composition. The drip tips also create visual interest in moonlight, with droplets forming, growing larger, catching and refracting light, and finally falling in an endless cycle. Some tropical plants have evolved drip tips that can be several inches long, creating dramatic streamers of water on particularly dewy nights. This feature is so effective that botanists have observed plants with drip tips collecting up to 30% more usable water than those without them. As the night progresses and we kneel beside a bed of evening stock, we discover another olfactory marvel. Evening stock, or Methyla longipetala, produces modest flowers in shades of pink, purple, and white that look rather unremarkable in daylight. The plants themselves are somewhat scraggly and informal, not the kind of specimen you'd give pride of place in a formal border. But gardeners who know the secret of evening stock plant them anyway, because what they lack in visual appeal they more than compensate for in fragrance. As darkness falls, these humble flowers release a scent that has been described as one of the most beautiful in all of horticulture, a rich, spicy-sweet perfume with notes of clove, vanilla, and something indefinably exotic. The fragrance of evening stock has an almost physical presence on the air, seeming to wrap around you like an invisible shawl. What's particularly interesting about this plant is that its fragrance production is triggered not just by darkness, but by the specific combination of darkness and cooling temperatures. On a warm night, the fragrance might be pleasant but relatively mild. On a cool night following a warm day, when the temperature differential is greatest, the fragrance becomes extraordinary, filling the air with such richness that it almost seems to have weight and substance. This temperature-dependent fragrance production ensures that the scent is strongest on nights when moth activity is highest, cool but not cold, still and calm, perfect for carrying scent molecules over long distances. Now let's explore a curious phenomenon that occurs with dew formation on spider webs. Throughout the garden, countless spiders have spent the day spinning their silken traps, and as night falls and dew begins to form, these invisible strands suddenly become visible, transformed into strings of diamonds catching moonlight. Each droplet of dew that condenses on spider silk creates a tiny lens, and the regular spacing of droplets along the strand creates patterns of almost mathematical precision. What you're witnessing is a beautiful demonstration of physics in action. Spider silk is hydrophobic, it repels water, but it's also covered in microscopic bumps and irregularities. When water vapor condenses on the silk, surface tension causes the tiny droplets to bead up. These beads then gradually slide along the strand until they encounter other beads, merging into larger droplets. The spacing between these droplets is determined by the interplay of surface tension, gravity, and the silk's natural properties, creating regular intervals that look almost deliberately designed. In Moonlight, a dew-covered spider web becomes a natural work of art, a necklace of captured light suspended in darkness. The spider, meanwhile, benefits from this dew accumulation. The water droplets actually strengthen the web's ability to capture prey and provide the spider with hydration it can consume by grooming its web. Nothing in the garden is wasted, even what seems purely aesthetic serves practical purposes in nature's economy. As we pause near a hedge of flowering tobacco, in Nicotiana alata, we encounter flowers that demonstrate yet another strategy for nighttime attraction. These tubular blooms remain closed or only partially open during the day, but as evening approaches, they open wide, revealing star-shaped faces that can be white, pink, or lime green depending on the variety. The white varieties, as you might expect by now, are most visible in Moonlight, but they have another trick in their arsenal. Their petals are covered with microscopic structures that don't just reflect light, they scatter it in multiple directions. This means that a moonflower tobacco blossom doesn't just glow when viewed from one angle, it appears luminous from almost any direction you approach it. These microscopic structures, too small to see without magnification, act like tiny satellite dishes, capturing light and broadcasting it outward. This makes the flowers visible not just to moths approaching head-on, but to those flying past at angles, significantly increasing the chances of attracting pollinators. Additionally, flowering tobacco produces a fragrance that intensifies at night, though unlike some of the more powerful night bloomers, its scent is gentle and sweet rather than overwhelming, just strong enough to carry on the breeze and guide moths in from moderate distances. The plant has calibrated its attractions perfectly, enough visual signal to be noticed, enough fragrance to provide direction, and enough nectar to reward visitors and ensure they'll return and tell their colleagues, so to speak, through the mysterious ways that pollinators communicate about productive food sources. Finally, as this second segment of our journey draws to a close, let's consider the role of the moon itself in the garden's nighttime ecology. While it might seem that moonlight is simply pale, reflected sunlight, which technically it is, the quality of moonlight has unique properties that affect both plants and pollinators in subtle ways. Moonlight is polarized, meaning its light waves vibrate in specific directions, and many insects can detect this polarization, using it for navigation in ways we're only beginning to understand. On nights of the full moon, when lunar illumination is at its peak, certain flowers experience measurably higher pollination rates because their moth pollinators can navigate more effectively, traveling farther and visiting more blooms. Some researchers have even found that certain plants time their peak blooming to coincide with full moon periods, though this remains an area of ongoing study. The moon's gravitational pull, the same force that creates ocean tides, may also influence the movement of water within plants, potentially affecting the timing of dew formation and guttation. Standing in a moonlit garden, you're not just witnessing a beautiful scene, you're observing a complex interplay of light, gravity, chemistry, and biology that has been fine-tuned over countless generations. The moon isn't just illuminating the garden, it's an active participant in the ecosystem, shaping behaviors and influencing outcomes in ways both obvious and subtle. As you return from this second wandering through the moonlit garden, perhaps you're beginning to see the night landscape differently. What once seemed like darkness is revealed as a realm of activity and purpose, where every scent serves a function, every dewdrop tells a story, and every bloom that opens in darkness is part of an ancient conversation between plants and their nighttime visitors. The garden at night isn't sleeping, it's simply speaking a different language, one we can learn to understand if we're patient enough to listen. In our next segment, we'll explore more of the creatures that share this nighttime realm, the ways that different types of dew and moisture affect various plants, and some of the most spectacular night-blooming species from around the world that you might add to your own garden. For now, as you drift toward sleep, imagine the gardens outside continuing their nocturnal routines, flowers opening, moths flying, dew forming, all beneath the patient gaze of the moon. As we return once more to the moonlit garden, the night has reached that profound depth where the boundary between late evening and early morning blurs into a timeless present. The moon, perhaps beginning its descent toward the western horizon, casts shadows that stretch and transform the familiar into something otherworldly. The dew is at its heaviest now, and the night-blooming flowers have reached their peak performance, filling the air with an intoxicating blend of fragrances. Let us continue our wandering, discovering new marvels with each careful step along the dampened path. Our journey in this segment begins with one of the most dramatic night bloomers you might encounter, the dragon fruit cactus, also known as pitaya or hylocereus. Like its cousin the night-blooming cereus, this remarkable plant produces flowers that open only at night, but the dragon fruit flower is even larger. Some blooms can reach 14 inches in diameter, making them among the largest night-blooming flowers in the world. Picture a flower nearly as wide as a dinner plate, with layers upon layers of creamy white petals surrounding a center filled with hundreds of delicate yellow stamens. These magnificent blooms begin their opening process just as twilight fades, and the transformation takes several hours to complete. What makes the dragon fruit flower particularly fascinating is its architectural complexity. The outer petals are often tinged with pink or green, while the inner petals are pure white, creating a gradient effect that seems to capture and hold whatever light touches it. The flower doesn't just open, it unfurls in stages, like a slow-motion firework, each layer of petals spreading wider until the bloom achieves its full, spectacular diameter. The fragrance is subtle for such a large flower, sweet but not overpowering, a gentle vanilla scent that attracts bats and moths in equal measure. In tropical and subtropical regions where dragon fruit grows wild, local bat populations have become the primary pollinators, and the flowers have evolved to accommodate these flying mammals perfectly. The sturdy structure can support the weight of a visiting bat, and the abundant pollen and nectar provide a substantial meal. By sunrise, like all ephemeral night bloomers, the dragon fruit flower begins to wilt, its single night of glory complete. If successfully pollinated, it will develop into the exotic, bright pink fruit that has become increasingly popular in markets worldwide. As we move deeper into the garden, we encounter a phenomenon that reveals itself only in the quietest hours, the sound of flowers drinking dew. This might seem impossible. How can we hear something so subtle? But in the profound silence of a garden at night, when traffic has ceased and human activity has stilled, you can indeed hear the faint sounds of water being absorbed by plant tissues. When dew accumulates heavily on leaves and petals, gravity eventually causes some of these droplets to fall, landing on lower leaves or the soil below with the softest of taps. But some of this moisture is actively absorbed directly through the leaf surfaces in a process called foliar absorption. While plants primarily take up water through their roots, many species can also absorb moisture directly through their leaves when conditions are right. This process is nearly silent, but the cumulative effect of thousands of plant cells expanding as they fill with water creates minute sounds, tiny creaks and whispers that are more felt than heard if you press your ear close to a large, dew-covered leaf. Indigenous peoples in various parts of the world have long known about this phenomenon, sometimes describing it as the plants singing their gratitude for the night's moisture. Scientific studies have confirmed that plants can absorb significant amounts of water through their leaves, sometimes as much as 20% of their total water uptake in arid environments where dew is plentiful but rain is scarce. This foliar absorption is particularly important for epiphytic plants, those that grow on other plants without soil contact, which may rely almost entirely on dew, fog, and rain that contacts their leaves directly. Now let's explore one of the garden's most mysterious night bloomers, the night-blooming water lily, specifically Nymphea lotus, which produces spectacular white or pink flowers that open only after sunset. Unlike their day-blooming cousins that float serenely on pond surfaces throughout daylight hours, these nocturnal beauties remain tightly closed during the day, looking like simple green buds that you might not even notice. But as darkness falls, they begin their transformation. The sepals that protected the developing flower slowly separate, and the petals, sometimes numbering more than 20 per flower, begin to unfurl in a spiral pattern. What's particularly remarkable about night-blooming water lilies is their thermoregulation ability. These flowers can generate heat, raising their internal temperature by as much as 10 degrees Celsius above the ambient air temperature. This warmth serves multiple purposes. It helps volatilize the flower's fragrance, sending it farther across the water surface and into the air beyond. It creates a comfortable microclimate for visiting beetles, which are the primary pollinators for many water lily species, and on cool nights, it may help protect the flower's reproductive structures from cold damage. If you were to carefully touch the center of a night-blooming water lily at the peak of its opening, you would feel this warmth, a living flower generating heat like a tiny furnace. The beetles that pollinate these flowers are attracted not just by fragrance and the promise of pollen to eat, but by this warmth, which offers them a cozy refuge on cool nights. Some beetles become so comfortable in the warm, fragrant chambers of these flowers that they spend the entire night inside, inadvertently providing excellent pollination as they move around eating pollen and drinking nectar. As we pause beside a trellis covered in climbing plants, we discover honeysuckle vines just beginning their nightly performance. Honeysuckle flowers, particularly the native Japanese honeysuckle or Lonicera japonica, demonstrate a color-changing ability that serves a clever purpose. The flowers emerge white or very pale yellow, and during their first night of opening, they produce abundant nectar and are highly fragrant. They're essentially advertising their availability to pollinators with everything they have: color, scent, and reward. But if a flower is successfully pollinated during that first night, it begins to change color over the following day, shifting from white to golden yellow, and eventually to a deeper amber or orange tone. This color change serves as a signal to pollinators. Fresh, white flowers are advertising that they have full nectar reserves and are ready for pollination, while the darker, golden flowers are essentially putting up a closed for business sign. This benefits both plant and pollinator. The plant doesn't waste resources producing nectar in already pollinated flowers, and the pollinators don't waste time and energy visiting flowers that offer no reward. It's an elegant communication system that has evolved over countless generations. The fragrance of honeysuckle at night is legendary, a sweet, heady perfume that can carry across remarkable distances. In traditional gardens, honeysuckle was often planted near windows and doorways so its evening fragrance could drift indoors. The scent has a soporific quality that many find deeply relaxing, contributing to the peaceful atmosphere of the nighttime garden. Continuing our exploration, we come upon a fascinating aspect of dew formation that you can observe on certain plants: the creation of dew rings or dew halos. Some plants with broad, flat leaves positioned horizontally develop a peculiar pattern where dew forms most heavily in a ring around the perimeter of the leaf while the center remains relatively dry. This occurs because of subtle temperature differences across the leaf surface. The edges of the leaf, having more surface area exposed to air and thus radiating heat more efficiently, cool down faster than the center, which retains warmth longer. As a result, the edges reach the dew point temperature first, and water begins condensing there while the center is still too warm. As the night progresses and the center eventually cools, you might see the dew pattern expand inward, gradually filling the entire leaf surface. But on some plants, particularly those with water-repellent surfaces in the center of the leaf, this ring pattern persists all night, creating beautiful circular patterns of moisture that catch moonlight like nature's own jewelry design. Lotus leaves are famous for this effect, their superhydrophobic centers causing water to bead up and roll away while the edges collect traditional dew patterns. Observing these dew rings in moonlight reveals the invisible architecture of temperature and airflow that exists around every leaf, usually hidden from our senses but made visible through condensation. As we venture near a section of the garden where herbs grow, we encounter another nocturnal wonder, night-scented stock, or Moths bicornis. This plant is the close relative of the evening stock we met in our previous segment, but it has evolved an even more specialized relationship with darkness. Night-scented stock produces flowers so inconspicuous that you might never notice them in daylight, small, dull lilac or brownish blooms that close tightly and seem determined to avoid attention. The plant itself is rather weedy in appearance, with thin stems and sparse foliage. You might wonder why anyone would cultivate such an unprepossessing specimen. But then night falls, and everything changes. As darkness deepens, the modest flowers open, and they release a fragrance so exquisite and powerful that it justifies the plant's entire existence. The scent has been described as a complex blend of honey, almonds, violets, and something mysteriously spicy that defies easy description. What makes this fragrance particularly interesting is its pulsing quality. It doesn't release at a constant level but instead comes in waves, growing stronger, then fading slightly, then strengthening again. This pulsing pattern is controlled by the plant's internal chemistry, which produces scent compounds in bursts rather than continuously. The effect for anyone standing nearby is almost magical. The fragrance seems to wash over you in waves, each one slightly different in character from the last. This pulsing release may help the scent travel farther, as each burst creates a new scent plume that can be carried on air currents, potentially reaching pollinators at greater distances than a constant release could achieve. Now let's turn our attention to a remarkable adaptation found in many night-blooming plants, the ability to track the moon's position across the sky. While we're all familiar with heliotropism, the tendency of some flowers to track the sun, fewer people know about selenotropism, or moon tracking. Certain night-blooming species, including some moonflowers and evening primroses, exhibit a subtle ability to orient their flowers toward the brightest source of light in the night sky. This isn't as dramatic as sunflower tracking, which can see flowers turning nearly 90 degrees to follow the sun, but careful observation reveals that night bloomers on the eastern side of a plant often face slightly different directions than those on the western side. They're orienting themselves to maximize the amount of moonlight falling on their petals, which in turn maximizes their visibility to pollinators. The mechanism behind this is still not fully understood, but it appears to involve the same photoreceptor proteins that enable sun tracking in day-blooming plants, just calibrated to respond to much lower light levels. On nights of the full moon, this tracking behavior is most pronounced. By morning, the flowers may have shifted position slightly as they followed the moon's arc across the sky. This subtle movement represents millions of years of evolution fine-tuning the relationship between flowers and their pollinators, creating responses to light levels that seem impossibly faint to our human senses. As we kneel beside a bed of sweet alyssum, we discover another nighttime secret. This common bedding plant, often dismissed as merely a daytime ground cover, produces a fragrance that intensifies significantly after dark. During the day, sweet alyssum emits a pleasant honey-like scent, but it's relatively mild, easily overlooked among showier garden fragrances. But as evening temperatures drop and darkness settles, the fragrance production increases dramatically, transforming this humble plant into a powerhouse of perfume. The scent, reminiscent of honey with undertones of vanilla and a slight almond-like character, becomes strong enough to fill entire sections of the garden. This evening intensification serves the plant's reproductive strategy, while sweet alyssum is small and low-growing, making it less visible to daytime pollinators that tend to focus on taller, more colorful blooms. The powerful nighttime fragrance allows it to compete for the attention of moths and other nocturnal insects. The plant essentially shifts its marketing strategy. By day, it offers visual appeal to whatever pollinators notice it, but by night, it becomes an olfactory powerhouse that compensates for its small stature. Gardeners who plant sweet alyssum along pathways or near seating areas often report being surprised by how much fragrance such a small plant can produce once the sun sets, creating living borders of perfume that guide visitors through the moonlit garden. Finally, as this third segment of our wandering draws toward a close, let's explore the phenomenon of lunar halos and how they transform the nighttime garden experience. On certain nights, particularly when high, thin cirrus clouds drift across the sky, you might notice a luminous ring around the moon, a lunar halo created by moonlight refracting through ice crystals in the upper atmosphere. These halos typically appear at a radius of 22 degrees from the moon, creating a perfect circle of soft, diffuse light in the night sky. For the garden below, a lunar halo creates a distinctly different quality of illumination than direct moonlight. The light is softer, more diffused, coming from a broader area of sky rather than a single point source. This diffusion reduces harsh shadows and creates a gentler, more even illumination across the garden. White flowers don't gleam quite as brightly, but they glow more uniformly. Dewdrops sparkle with a softer light. The entire garden takes on an ethereal quality, as if viewed through a very fine veil. Many cultures have traditions and folklore surrounding lunar halos, often considering the importance of changing weather, and there's truth to this, as the cirrus clouds that create halos often precede weather fronts by 24 to 48 hours. Standing in a garden beneath a lunar halo, surrounded by night-blooming flowers and dew-laden leaves, you're experiencing a confluence of atmospheric optics, botanical adaptation, and simple beauty that connects you to countless generations of nighttime observers who have paused in gardens before you, looking up in wonder at the same celestial phenomenon. The moonlit garden continues to unfold its mysteries, layer upon layer, each observation revealing new connections and relationships. What seems at first like simple beauty reveals itself, upon closer inspection, to be a complex web of adaptations, strategies, and responses to environmental conditions. The night-blooming flowers aren't just pretty, they're sophisticated solutions to the challenge of reproduction in darkness. The dew isn't just moisture, it's a resource, a visual enhancer, and a window into the physics of heat and condensation. Even the moon itself isn't just a light source, it's a gravitational force, a navigation aid, and a timekeeper for countless organisms. As you prepare to leave this third wandering, take with you the knowledge that the garden at night is never truly still, never truly quiet, never truly dark. It pulses with life and purpose, with ancient rhythms and modern moments, with the patient unfurling of petals and the silent formation of dewdrops. Each element exists in relationship to all the others, creating a symphony of interaction that plays out beneath the moon's gentle gaze. In our next segment, we'll explore even more specialized night bloomers, the role of specific pollinator species, and the ways that different seasons transform the nighttime garden experience. For now, rest peacefully, knowing that gardens everywhere are conducting their nocturnal business with elegance and purpose. We return once again to the moonlit garden, where the night has matured into that peculiar hour when darkness feels most complete, yet somehow most alive. The constellations have wheeled overhead, marking the passage of time in their ancient patterns, and the garden has settled into its deepest nocturnal rhythms. The flowers that opened at dusk are now at their fullest glory, and new wonders await our discovery. Let us continue our wandering, stepping carefully along paths where dew has made every surface glisten like scattered starlight. Our exploration in this segment begins with one of the most fragrant and culturally significant night bloomers, tuberose, known scientifically as Polyanthus tuberosa. These elegant flowers, borne on tall spikes that can reach 3 feet in height, produce waxy white blooms that remain tightly closed during daylight hours. But as the sun sets and temperatures begin to drop, the tuberose flowers begin their transformation, opening gradually to reveal their creamy white petals arranged in perfect spirals. What makes tuberose truly extraordinary, however, is its fragrance, widely considered one of the most intoxicating and complex perfumes in the entire plant kingdom. The scent of tuberose is so powerful and distinctive that it has been a cornerstone of the perfume industry for centuries, featured in some of the world's most expensive and sought-after fragrances. The aroma is intensely sweet, almost narcotic in its richness, with layers that reveal themselves over time. Initial impressions suggest honey and orange blossom, but as you breathe more deeply, you detect undertones of coconut, jasmine, and something slightly spicy and exotic that defies easy categorization. What's particularly remarkable about tuberose is that a single stem bearing multiple flowers can perfume an entire room or a large section of garden. The fragrance intensifies throughout the night, reaching its peak in the hours around midnight when the flowers are fully open and their pollinator moths are most active. In some tropical cultures, tuberose flowers are traditionally offered at temples or worn in the hair during evening ceremonies, their fragrance believed to create a bridge between the earthly and spiritual realms. The intensity of the scent can be almost overwhelming in enclosed spaces, which is why some people prefer to enjoy tuberose outdoors, where the night breezes can temper and distribute the fragrance. After experiencing tuberose in a moonlit garden, you'll never forget it. The scent becomes a sensory memory that can transport you back to that moment with startling vividness. As we move along a stone wall where climbing plants have taken hold, we encounter a fascinating phenomenon related to dew formation, the creation of dew tracks. Certain insects, particularly snails, and slugs that are active primarily at night, leave behind trails as they move across dew-covered surfaces. These creatures are attracted to the moisture-rich environment created by heavy dew, and as they travel across leaves and stems, they disturb the fine layer of dewdrops, creating paths that appear as darker lines against the silvery dew-covered surfaces. In bright moonlight, these trails become visible, creating intricate patterns that map the nocturnal wanderings of creatures we rarely see. What's particularly interesting is that these tracks can tell us stories about the garden's hidden ecosystem. A trail leading from soil level up a stem to a particular leaf might indicate a slug heading toward a favorite feeding spot. Multiple intersecting trails might show a popular corridor used by many individuals. By morning, as the dew evaporates, these tracks disappear, making them truly ephemeral art that exists only in the nighttime hours. Some of these nighttime travelers also contribute to the garden's ecology in unexpected ways. As they move through dew, they inadvertently disperse microscopic algae and beneficial bacteria across leaf surfaces, creating microhabitats that support other tiny organisms. The dew tracks you observe are evidence of a complex web of nocturnal activity that occurs largely unnoticed, a reminder that the quiet garden is anything but still. Now let's explore one of the most unusual night bloomers you might encounter, the Dutchman's pipe cactus, or Epiphyllum oxypetalum, another member of the night-blooming cereus family. This plant produces flowers of such extraordinary beauty and size that they seem almost unreal, blooms that can measure up to 12 inches across with long, elegant petals that taper to delicate points. The flowers are pristine white with a subtle cream-colored center, and they possess an architectural quality that makes them look almost sculpted rather than grown. What makes the Dutchman's pipe cactus particularly fascinating is the speed of its bloom opening. While many night flowers open gradually over hours, this species can go from a tightly closed bud to full bloom in as little as 60 to 90 minutes, a transformation so rapid you can literally watch the petals unfurling in real time if you have the patience to observe. The flower begins its opening just after sunset, and the process accelerates as darkness deepens. The outer petals separate first, peeling back like the layers of an exotic fruit, and then the inner petals unfurl in a spiral pattern, each one positioning itself with precision. The stamens in the center extend outward as the flower opens, reaching their full length just as the petals achieve maximum spread. The fragrance that accompanies this display is subtle but distinctly pleasant, reminiscent of vanilla with hints of lily. Like all night-blooming cereus species, each flower blooms for only one night, making the experience of witnessing this rapid unfurling all the more precious. Collectors of these plants often host viewing parties when they anticipate a bloom, gathering friends and family to witness this natural wonder together. The sense of shared anticipation and collective awe when the flower finally opens creates a communal experience that connects people through appreciation of nature's ephemeral beauty. As we venture near a water feature in the garden, perhaps a small pond or fountain, we discover how moving water interacts with moonlight and dew in fascinating ways. The surface of still water reflects moonlight like a mirror, creating a second moon in the garden below the one in the sky. But moving water breaks this reflection into countless dancing points of light, each ripple and wave creating its own momentary mirror that catches and releases the lunar glow. When dew forms on plants surrounding a water feature, the combination of reflected moonlight from the water surface and direct moonlight from above creates complex patterns of illumination. Plants near water often collect more dew than those in drier areas because the local humidity is higher. Water evaporating from the pond or fountain increases the moisture content of the surrounding air, making it reach the dew point more easily. This creates a microclimate where dew formation is particularly abundant, and in bright moonlight, the plants around a water feature can appear to be covered in liquid silver, each leaf and petal encrusted with moisture. The sound of water moving, whether it's a fountain's gentle splash or a small waterfall's steady rush, also affects how we perceive the garden at night. These sounds mask more distant noises, creating an envelope of tranquility that makes the garden feel like a separate world, insulated from everything beyond its boundaries. The combination of visual beauty, moonlight on water and dew, and auditory pleasure creates a multisensory experience that enhances the meditative quality of nighttime garden wandering. Continuing our journey, we encounter the night-blooming gladiolus, Gladiolus tristis, a species quite different from the familiar day-blooming gladiolus varieties commonly grown for cut flowers. This South African native produces slender spikes of pale yellow or cream-colored flowers that remain closed during the day but open in the evening to release one of the most powerful fragrances in the gladiolus family. The scent is sweet and spicy simultaneously, with prominent notes of clove and cinnamon mixed with floral sweetness. What's particularly interesting about night-blooming gladiolus is that individual flowers on the spike open sequentially over many nights rather than all at once. The lowest flowers on the spike open first, and over the course of a week or more, the blooming progresses upward, with new flowers opening each evening as lower ones fade. This sequential blooming strategy extends the plant's flowering period and provides a reliable nectar source for pollinators over multiple nights. The flowers are specifically shaped to accommodate long-tongued moths, with narrow tubes that prevent access by insects with shorter mouthparts. This exclusivity ensures that only the most effective pollinators, those that will reliably visit many flowers and transfer pollen between plants, receive the nectar reward. In moonlight, the pale yellow flowers have a subtle glow, not as dramatic as pure white blooms but beautiful in their own soft way, like candlelight rather than electric light. Now let's explore a remarkable aspect of plant behavior that becomes apparent only through nighttime observation, the phenomenon of sleep movements, or nyctinasty. Many plants, even those that don't bloom at night, undergo dramatic changes in leaf or petal position between day and night. The sensitive plant or Mimosa pudica is famous for folding its leaves when touched, but fewer people know that it also folds them automatically every night even without stimulation. Prayer plants, with their beautifully patterned leaves, fold their foliage upward at night, hence their common name, the leaves rise like hands in prayer. These movements are controlled by specialized cells at the base of leaves or leaflets that regulate water pressure, causing the plant parts to move. The adaptive value of these sleep movements is still debated among botanists, but several theories exist. Folded leaves may conserve moisture by reducing the surface area exposed to cool night air, minimizing dew formation that could promote fungal growth. Upright leaves may also prevent excessive cooling from radiation to the night sky, helping maintain warmer temperatures in the plant's core. For prayer plants specifically, the nighttime folding displays the undersides of leaves, which are often burgundy or purple-colored. Some researchers speculate this darker coloration may help the plant warm up more quickly when morning sun arrives, absorbing light more efficiently than the patterned upper surfaces. Watching these sleep movements in a moonlit garden is mesmerizing. As darkness falls, you can observe leaves slowly folding, petals closing, entire plants rearranging themselves for the night. It's a reminder that plants are far more dynamic than we typically imagine, constantly responding to environmental cues and adjusting their forms to optimize survival. As we pause near a border of white petunias, we discover that even common garden plants can have nocturnal secrets. While petunias are typically thought of as daytime bloomers, white varieties in particular intensify their fragrance significantly after sunset. During the day, petunias have a pleasant but relatively mild scent. But as evening approaches, and especially on warm, humid nights, white petunias release a fragrance that's much stronger and more complex, with sweet, slightly fruity notes that can perfume a considerable area. This evening fragrance intensification isn't as dramatic as in dedicated night bloomers like angels, trumpet, or jasmine, but it's noticeable enough that gardeners who plant white petunias near seating areas or pathways often comment on the pleasant surprise of discovering their enhanced nighttime perfume. The fragrance attracts sphinx moths and other nocturnal pollinators, giving the petunias access to pollination services that aren't available during the day when bee activity dominates. This dual strategy, attracting both day and night pollinators, increases the plant's reproductive success and demonstrates that the boundary between day-blooming and night-blooming plants isn't always absolute. Many species operate in both realms, adjusting their offerings to appeal to whichever pollinators are currently active. Now let's turn our attention to a peculiar type of dew that forms under specific conditions, frost dew, also called white dew. On nights when temperatures drop close to but not quite reaching the freezing point, dew can form and then begin to freeze, creating a hybrid between liquid dew and frost. This frost dew appears as white or translucent crystals mixed with liquid droplets, creating a sparkling effect that's distinct from either pure dew or pure frost. The formation of frost dew requires precise conditions. Temperatures must be in a narrow range, typically between 32 and 36 degrees Fahrenheit, and the cooling must happen gradually enough that dew forms first before freezing begins. In Moonlight, frost dew creates an extraordinary display, with some droplets remaining liquid and spherical while others have begun crystallizing into geometric ice structures. The partially frozen droplets refract light differently than liquid dew, creating rainbow effects and unusual sparkles. Plants covered in frost dew have a magical appearance, as if they've been decorated with both diamonds and ice crystals simultaneously. This phenomenon is most common in spring and fall when nighttime temperatures can drop dramatically but the season isn't cold enough for hard frosts. Observing frost dew formation can also serve as a practical warning. It indicates that temperatures are approaching the freezing point, and tender plants may need protection if the night grows any colder. Finally, as this fourth segment of our wandering approaches its conclusion, let's explore the extraordinary night-blooming Amazon water lily, Victoria amazonica, one of the largest and most spectacular aquatic plants in the world. This giant water lily produces leaves that can exceed 6 feet in diameter, with upturned edges that make them look like enormous green platters floating on the water surface. But it's the flowers that concern us in our moonlit wandering. Victoria amazonica produces blooms that can measure up to 16 inches across, making them among the largest flowers in the plant kingdom. These flowers follow a remarkable two-night blooming cycle that involves a dramatic color change and an ingenious pollination strategy. On the first evening, the flower opens at dusk, revealing pristine white petals arranged in multiple layers around a center chamber. The flower is female at this stage, receptive to pollen but not yet producing its own. It releases a powerful, sweet fragrance reminiscent of pineapple and butterscotch, which attracts specific species of scarab beetles. As beetles arrive, lured by the scent, they crawl inside the flower's chamber, which then closes, trapping them inside for the entire day. The trapped beetles are well-treated prisoners, the flower provides them with nutritious food bodies to eat, and the chamber maintains a temperature several degrees warmer than the outside air. On the second evening, the flower opens again, but now it has transformed. The white petals have turned deep pink or purplish red, and the flower's sex has changed. It's now male, producing abundant pollen but no longer receptive to receiving it. The beetles, now covered in pollen from their overnight stay, are released and fly off to find new white flowers, carrying their pollen payload with them. This ensures cross-pollination while preventing self-pollination. The color change from white to pink serves as a signal to beetles. White flowers are advertising that they're receptive and offering a warm shelter and meal, while pink flowers are essentially saying, already pollinated, nothing to offer here. This sophisticated system represents millions of years of evolution, creating a partnership so specialized that both beetle and flower are now dependent on each other for reproduction. As you step back from the pond where this magnificent lily floats, its white blooms glowing in the moonlight while yesterday's pink flowers bob beside them, you're witnessing a living demonstration of nature's endless creativity. The moonlit garden isn't just beautiful, it's functional beauty, every color, scent, and structure serving purposes refined over countless generations. The dew that catches the light isn't merely decorative, it's water, resource, signal, and canvas all at once. As this fourth wandering comes to a close, carry with you the understanding that nighttime gardens operate according to rhythms and rules quite different from their daytime counterparts. The plants that thrive here have made fundamental changes to their biology, restructuring when they bloom, how they attract pollinators, and even how they move and position themselves. In our next segment, we'll explore more about the seasonal variations in nighttime gardens, specific pollinator relationships, and some of the rarest and most unusual night-blooming species from around the world. For now, rest in the knowledge that the garden continues its ancient dance beneath the moon, patient and purposeful in darkness. We gather ourselves once more for another journey into the moonlit garden, where the night has reached that crystalline quality that comes in the hours before dawn. The air is at its coolest now, the dew at its heaviest, and the garden seems to hold its breath in anticipation of the coming sunrise. Yet there are still wonders to discover, still secrets the darkness holds close. Let us continue our wandering through this realm where petals unfold in shadow and moisture transforms into jewelry. Our exploration in this segment begins with one of the most mystical of all night bloomers, the ghost orchid, Dendrophylax lindenii, a rare and ethereal flower that seems to float in mid-air like an apparition. This remarkable orchid is leafless, existing as a tangle of greenish-gray roots that cling to tree bark in swampy forests. For most of the year, the ghost orchid is nearly invisible, its roots blending with the bark of its host tree. But when it decides to bloom, which happens unpredictably and infrequently, it produces one of the most otherworldly flowers in existence. The bloom itself is pristine white, with long, trailing petals that can extend up to 4 inches, creating a shape that resembles a ghost or a flying spirit, hence the common name. The flower appears to levitate because the stem connecting it to the roots is so thin as to be nearly invisible, especially in low light conditions. What makes the ghost orchid relevant to our nocturnal wanderings is that it releases its fragrance primarily at night, a sweet, apple-like scent designed to attract its specific pollinator, the giant sphinx moth. This moth, with its remarkably long proboscis, is one of the few creatures capable of reaching the nectar hidden deep within the orchid's spur-like structure. The relationship between ghost orchid and moth is so specialized that the flower has essentially bet its entire reproductive future on this single pollinator species. On moonlit nights in the swamps where ghost orchids grow wild, the sight of these white flowers seeming to float among the trees, releasing their delicate fragrance into the humid air, has inspired countless legends and stories. Some people report that the flowers seem to glow with their own light, though this is likely an optical illusion created by their pure white color and the way they reflect whatever moonlight filters through the forest canopy. Standing before a blooming ghost orchid on a moonlit night is considered a rare privilege, a moment of connection with something almost supernatural in its beauty and mystery. As we move through a section of the garden where herbs have been planted, we encounter a fascinating phenomenon: the difference in essential oil concentration between day and night. Many aromatic herbs, including basil, mint, and oregano, produce significantly different levels of essential oils depending on the time of day and environmental conditions. During hot, sunny days, many herbs actually reduce their volatile oil production or store these compounds in ways that minimize evaporation. But as evening approaches and temperatures cool, these plants adjust their chemistry. Night-harvested herbs often have markedly different aromatic profiles than those harvested during the day. This occurs because cooler nighttime temperatures slow the evaporation of volatile compounds, allowing them to accumulate in higher concentrations in the plant tissues. Additionally, the absence of intense sunlight means the plants aren't breaking down certain aromatic compounds through photochemical reactions. Traditional herbalists have long known this secret, often harvesting medicinal and culinary herbs in the early morning hours just after dawn, when nighttime oil accumulation is at its peak but before the sun has driven off these precious compounds. In a moonlit garden, if you gently brush your hand across a basil plant or crush a mint leaf between your fingers, the fragrance that releases may be noticeably more intense and complex than the same action would produce at midday. The dew clinging to these herb leaves also plays a role. The moisture can help carry aromatic molecules to your nose more effectively, creating a more powerful scent experience. This is why herb gardens can smell particularly wonderful in the early morning or late evening hours, when dew and optimal oil concentrations combine to create peak aromatic conditions. Now let's explore one of the most dramatic night bloomers from the tropical world, the Queen of the Andes, or Puya raymondii. While this plant doesn't bloom frequently, in fact, it may take 80 to 100 years to produce its first and only flower spike. When it does bloom, the display is unforgettable. The plant produces a flower spike that can tower over 30 feet tall, making it the largest flower spike in the world. This enormous structure bears thousands of individual flowers, and while the plant blooms during the day as well, many of its flowers specifically open at night to attract bat pollinators. The flowers produce copious amounts of nectar, and the nighttime opening blooms are specially positioned on the spike to be accessible to bats approaching from below. What makes this relevant to our moonlit wandering is the incredible sight of such a massive flower spike standing against the night sky, with hundreds of flowers open simultaneously, each one glistening with nectar and dew. In the high Andes where these plants grow wild, indigenous peoples have traditionally timed important ceremonies and gatherings to coincide with the rare blooming of a Puya raymondii, considering it an auspicious event. The plant dies after blooming, having invested everything in this single massive reproductive effort, making each bloom both a beginning and an ending. While few gardeners outside the Andes will ever grow this plant, its existence reminds us that the world of night-blooming plants includes species of staggering size and longevity, plants that measure their lives in decades and their blooms in thousands of individual flowers. As we pause beside a trellis where passion flowers grow, we discover that certain passion flower species are specifically adapted for night blooming. While many passion flowers bloom during the day, species like Passiflora cerealia have varieties that remain closed in daylight but unfurl in the evening hours. These night-blooming passion flowers often have paler coloration than their day-blooming cousins, whites, pale pinks, and light lavenders that show up better in low-light conditions. The intricate structure of passion flowers, with their complex arrangement of petals, corona filaments, and prominent stamens, creates a geometric pattern that seems almost deliberately designed to catch and reflect moonlight. Each flower becomes a small mandala of light and shadow, with the radiating corona filaments creating a starburst effect. The flowers produce a subtle, sweet fragrance at night, quite different from the more vegetal scent they might have during the day. This evening scent attracts night-flying moths that navigate the complex architecture of the bloom to reach the nectar at its base. What's particularly beautiful about observing passion flowers in moonlight is how the dew collects in their intricate structures. Water droplets accumulate along the corona filaments like beads on strings, and larger drops gather in the cup formed by the petals. The flower essentially becomes a collection vessel for dew, and in bright moonlight, these water-filled blooms sparkle with an intensity that seems almost magical. By morning, the accumulated dew provides moisture for visiting insects and can even be absorbed directly by the flower's tissues, demonstrating once again how dew serves multiple purposes beyond simple beauty. Continuing our wandering, we come upon an aspect of nighttime gardens that many people never notice: the phenomenon of photon accumulation in certain white flowers. Some night-blooming plants with white petals have evolved cell structures that act somewhat like fiber optics, channeling whatever light is available toward the center of the flower where the reproductive structures are located. This isn't true bioluminescence. The flowers aren't generating their own light, but rather an extremely efficient use of reflected and refracted moonlight and starlight. The petals of these flowers contain microscopic structures that capture photons and direct them inward, creating the illusion that the flower center is glowing more brightly than the outer petals. This serves a practical purpose. By concentrating available light at the flower center, the plant creates a visual target for pollinators, essentially putting a spotlight on exactly where the pollinator needs to go. Scientists studying this phenomenon have found that some white flowers can concentrate light at their centers to levels that are measurably higher than the ambient moonlight striking their outer petals. For a moth approaching such a flower in darkness, this concentrated light serves as a precise landing beacon. The effect is subtle and requires careful observation to notice, but once you know to look for it, you can see that certain night-blooming flowers do indeed appear to have brighter centers, as if illuminated from within. This represents yet another layer of sophistication in the evolutionary adaptations that make night blooming successful. As we venture near the garden's edge where it meets a wooded area, we might encounter one of the most fragrant of all native North American night bloomers, the wild plum or American plum, Prunus americana. While plum trees bloom in early spring, a season when nights can still be quite cool, many people don't realize that plum blossoms release their strongest fragrance during nighttime hours. The small white flowers, which bloom in clusters before the tree's leaves emerge, produce a scent that's rich, sweet, and slightly almond-like, a characteristic of many plants in the rose family. On a warm spring evening when a plum tree is in full bloom, the fragrance can carry for remarkable distances, sometimes several hundred feet on a gentle breeze. This powerful nighttime scent serves to attract early-season moths and other nocturnal insects that are active during the transitional period between winter and full spring. The tree essentially hedges its bets by appealing to both day-active bees and night-active moths, maximizing its chances of successful pollination during the brief period when conditions are right for bloom. What makes plum blossoms particularly lovely in moonlight is their tendency to bloom in such profuse clusters that the bare branches seem covered in snow. The white blooms reflect moonlight brilliantly, creating a luminous effect that can make the entire tree appear to glow against the darkness of the still leafless surrounding forest. Standing beneath a blooming plum tree on a moonlit spring night, surrounded by its heady fragrance and watching the occasional moth visit the flowers, you experience a moment of pure seasonal transition, the garden moving from winter's dormancy toward summer's abundance. Now let's explore the role of lunar phases in night garden activities. While the full moon provides maximum illumination and creates the most dramatic visual effects, different moon phases affect the garden in distinct ways. During the new moon, when the night sky is darkest, many night-blooming flowers actually intensify their fragrance production to compensate for reduced visibility. Without moonlight to help pollinators locate flowers visually, scent becomes even more critical. Research has shown that certain night-blooming species produce measurably more scent compounds during new moon periods than during full moon periods. Conversely, during the full moon, some plants may reduce fragrance production slightly and instead invest more energy in maintaining maximum petal reflectivity and size. The garden's character shifts with the lunar cycle. Full moon nights emphasize visual beauty, new moon nights emphasize scent and sound, and the quarter moons provide a balance between the two. Dew formation is also affected by moon phase, though indirectly. Clear nights that allow for the best moon viewing, whether full or new, also tend to promote heavy dew formation because cloud cover is minimal, allowing surfaces to radiate heat efficiently. Overcast nights may have poor visibility regardless of moon phase and often produce less dew because clouds trap heat and prevent the surface cooling necessary for condensation. Observing your garden through a complete lunar cycle reveals these patterns and creates a deeper appreciation for how interconnected all these nighttime phenomena truly are. As we kneel beside a bed of night phlox, Celusianskia ovata, we encounter a flower with one of the most delightful fragrances in the entire night garden. This South African native produces small flowers with white interiors and burgundy or dark red exteriors. During the day, the flowers close, showing only their dark backs and appearing rather somber. But as evening approaches, they open to reveal their white faces, and they release a fragrance that has been compared to honey almond and vanilla, with a sweetness that's intense but never cloying. What's particularly charming about night phlox is that individual flowers open and close on a precise schedule that you can almost set your watch by. They begin opening around 4 or 5 in the afternoon and are fully open by sunset. They remain open throughout the night, closing again as morning light strengthens. This reliable rhythm makes night phlox a perfect plant for evening gardens where people gather at predictable times. The flowers will dependably be open and fragrant for early evening entertainment or late night relaxation. The fragrance carries well on the air, so even a small planting of night phlox can perfume a considerable area. In moonlight, the contrast between the dark flower backs and white faces creates a striking pattern, almost like a checkerboard, as flowers at different stages of opening show varying amounts of their white interiors. Bees and butterflies largely ignore night phlox during the day when the flowers are closed, but as evening falls, moths of various sizes arrive to feed, drawn by the powerful fragrance and the visual beacon of the white flower faces. Finally, as this fifth segment of our wandering draws toward its close, let's consider the phenomenon of dew retention and how different plant structures hold moisture for varying lengths of time. Some plants shed their dew quickly as morning temperatures rise. Smooth, waxy leaves allow water to slide off easily, and plants with vertical or downward-facing foliage let gravity do the work of shedding moisture. But other plants have evolved structures that hold dew well into the morning hours, extending the benefits of this nighttime moisture. Plants with fuzzy or hairy leaves often retain dew longest because the tiny hairs create surface tension that holds water droplets in place even as temperatures rise. Cup-shaped leaves collect dew in small pools that evaporate slowly. Some bromeliads and similar plants have evolved into such efficient dew collectors that they maintain small reservoirs of water at their centers, which serve as miniature ecosystems supporting insects, frogs, and other small creatures. Observing which plants in your garden retain dew longest can tell you something about their adaptation strategies and their country of origin. Mediterranean plants, evolved for dry conditions, typically shed dew quickly to prevent fungal issues. Tropical plants from cloud forests often retain moisture longer, adapted to environments where persistent dampness is normal. The pattern of dew retention across your garden creates a temporal mosaic. Some areas dry quickly as morning arrives, while others remain glistening and cool well into the morning hours, extending that liminal period between night and day. As we prepare to leave this fifth wandering through the moonlit garden, take a moment to appreciate the extraordinary diversity we've encountered. From ghost orchids floating like spirits in swampy forests to plum blossoms perfuming spring evenings, from herbs adjusting their chemistry with the setting sun to flowers that concentrate photons like living lenses, the night garden reveals itself as a realm of endless adaptation and beauty. Each plant has found its own solution to the challenge of thriving in darkness, its own strategy for attracting pollinators when vision is limited, its own method of managing moisture and temperature. Together, these individual strategies create a symphony of form and function, a garden that operates according to rhythms very different from those that govern the daylight hours. In our next segment, we'll explore more rare and unusual night bloomers, delve deeper into specific pollinator behaviors, and discover how seasonal changes transform the nighttime garden's character. For now, rest peacefully, knowing that gardens everywhere continue their patient work beneath the moon and stars. As we embark on yet another moonlit wandering, the night has reached that profound hour when time seems suspended between darkness and the first hints of approaching dawn. The garden rests in its deepest stillness, yet paradoxically, this is when some of its most remarkable activities reach their crescendo. The moon, now lower in the sky, casts longer shadows that transform familiar spaces into mysterious grottos and hidden alcoves. Let us continue our exploration of this nocturnal wonderland, where every step reveals another layer of beauty and purpose. Our journey in this segment begins with one of the most spectacular night bloomers from the desert regions, the saguaro cactus blossom, the state flower of Arizona. These magnificent cacti, which can live for over 200 years and grow to heights of 40 feet or more, produce creamy white flowers that open exclusively at night during the late spring months. The blooms appear near the top of the cactus, emerging from the arms and crown in clusters that can number in the dozens on a mature specimen. Each flower is about 3 inches across with a brilliant yellow center surrounded by numerous white petals that create a cup-like shape. What makes these flowers particularly remarkable is their extraordinarily brief blooming period. They open in the late evening, remain open throughout the night, and begin to close by mid-morning the following day, wilting completely by afternoon. This single night of glory is all each flower gets to accomplish its mission of pollination. The flowers produce abundant nectar and a delicate, melon-like fragrance that attracts a specific community of nighttime pollinators. While bees visit the flowers in early morning before they close, the primary pollinators are lesser long-nosed bats and white-winged doves that feed during the night. The bats are particularly efficient pollinators, visiting multiple saguaros in a single night and transferring pollen across considerable distances. Watching a saguaro in full bloom on a moonlit desert night is an unforgettable experience, the massive cactus crowned with dozens of white flowers glowing against the dark sky, with bats swooping in to feed while the night air carries the subtle sweetness of the blossoms. The image has become iconic in the American Southwest, representing the unexpected delicacy that can emerge from such harsh, thorny plants. As we move through a section of the garden planted with hostas, typically thought of as shade-loving foliage plants, we discover a nighttime secret that many gardeners overlook. Certain hosta varieties, particularly those with white or pale lavender flowers, are intensely fragrant at night. The tubular flowers, which might seem almost insignificant compared to the plant's dramatic foliage, open in the evening and release a perfume that has been compared to honeysuckle and lily, sweet and penetrating. Hosta plantaginia, sometimes called the August lily, is particularly famous for its nighttime fragrance. The large white flowers, which can measure 4 to 5 inches in length, are specifically structured to attract sphinx moths with their deep, narrow throats and night-release scent. In Asian countries where hostas originated, these plants have long been valued not for their foliage but for their fragrant flowers, which were traditionally planted near windows and seating areas to perfume evening hours. In a moonlit garden, the pale hosta flowers seem to hover above their broad leaves like small lanterns, and their fragrance, which might go completely unnoticed during the day, fills the air with sweetness. The leaves themselves, often variegated with white, cream, or silver markings, catch moonlight beautifully, creating patterns of light and shadow across the garden floor. Dew collects in the cupped centers of hosta leaves, forming perfect pools of water that reflect moonlight like scattered mirrors. By morning, these collected dewdrops often contain drowned insects and organic debris, providing the plant with a supplemental source of nutrients. The leaves function as small passive traps, benefiting from the moisture they collect. Now let's explore one of the most unusual aspects of nighttime plant behavior: the phenomenon of nocturnal blooming triggers in plants that normally bloom during the day. Certain environmental stresses or unusual conditions can cause some day-blooming plants to shift their blooming times to evening or nighttime hours. This typically occurs when daytime temperatures become excessively hot. The plant responds by delaying its flower opening until cooler evening temperatures arrive, protecting both the flowers and visiting pollinators from heat stress. Researchers have observed this behavior in various species, including some roses, morning glories, and hibiscus varieties that normally bloom strictly during daylight. When temperatures exceed certain thresholds, often around 95 degrees Fahrenheit, these plants may postpone opening until temperatures drop in the evening, essentially becoming temporary night bloomers. This adaptive flexibility demonstrates how plant behavior isn't rigidly fixed but rather responsive to environmental conditions. For gardeners, this means that during heat waves, the garden's character can shift. Plants that normally provide daytime color may instead reserve their blooms for evening and nighttime hours, creating an unexpectedly rich display after sunset. This is yet another reminder that plants are constantly reading and responding to their environment, making real-time decisions about when to bloom, how much fragrance to produce, and when to open or close their flowers based on complex calculations of temperature, humidity, light levels, and even time of day according to their internal circadian rhythms. As we venture near a vine-covered arbor, we encounter the chocolate vine, Akebia quinata, a vigorous climber that produces some of the most unusually scented flowers in the night garden. The small, dangling clusters of flowers are brownish-purple in color, not particularly showy in daylight, but they release a fragrance that intensifies dramatically after dark. The scent is unique and polarizing. Some people describe it as chocolate mixed with vanilla and spices, while others detect notes of cinnamon, clove, or even a slight medicinal quality. What everyone agrees on is that the fragrance is powerful and distinctive, utterly unlike any other flower scent. The chocolate vine's flowers are structured to hang downward, which helps protect the nectar from rain and also positions them perfectly for pollination by night-flying insects that approach from below. In its native range in East Asia, the plant is pollinated by various moth species attracted to both its unusual scent and its dark coloration, which, surprisingly, is visible to insects that perceive ultraviolet wavelengths invisible to human eyes. In Moonlight, the hanging flower clusters create an interesting visual effect, swaying gently in evening breezes and casting small, moving shadows against the arbor structure. The fragrance drifts on these breezes, creating pockets of intense scent followed by clearer air, then another wave of fragrance, a sensory experience that adds dimension to walking through a moonlit garden. By morning, the flowers may have been visited by numerous insects, and if pollination is successful, the plant will produce elongated purple fruits that are edible and sweet, though rarely seen on plants grown outside their native range. Continuing our exploration, we discover a fascinating interaction between dew and leaf shape that creates natural drinking fountains for small creatures. Plants with long, narrow leaves arranged in rosette patterns, such as yuccas, agaves, and certain grasses, channel dew toward their centers, creating concentrated collection points where water accumulates throughout the night. These natural water collectors serve the plants by directing moisture toward their root zones, but they also provide vital drinking water for insects, birds, and small mammals. In arid regions where nighttime dew may be one of the few reliable moisture sources, these plant-created water stations become crucial elements of the ecosystem. Observing such plants on a dewy night reveals tiny dramas playing out in miniature, ants following established trails to drinking spots, beetles clustering around droplets, even small lizards lapping water from leaf margins. The dew that forms on these strategically shaped leaves isn't just passively present, it's being actively collected and concentrated by plant architecture that has evolved to harvest moisture from the air. Some desert plants have taken this strategy to remarkable extremes, with leaf surfaces covered in microscopic channels and grooves that guide water droplets with precision, funneling them toward specific collection points. In bright moonlight, you can sometimes see water moving along these channels, flowing in defiance of obvious logic until you realize the plant has essentially created a plumbing system at the microscopic level, managing water with an efficiency that human engineers would envy. As we pause beside a night-blooming water lily pond, we witness another remarkable phenomenon, the synchronized blooming of multiple water lilies. While we discussed the Victoria amazonica in an earlier segment, tropical water lilies of various species exhibit similar nighttime blooming behavior, and when multiple plants bloom simultaneously, the effect is breathtaking. The pond's surface becomes dotted with white or pink flowers, each one reflecting moonlight and creating an illusion of floating lanterns. What's particularly interesting is that water lilies in the same pond tend to synchronize their blooming cycles, with multiple flowers opening on the same nights. This synchronization occurs because the plants are all responding to the same environmental cues: water temperature, day length, and lunar cycles all play roles in triggering bloom development. The synchronized blooming serves a practical purpose. By having many flowers open simultaneously, the plants increase the chances that pollinators will move between different individual plants rather than just visiting flowers on a single plant, thus promoting cross-pollination and genetic diversity. On a warm summer night when a pond full of water lilies opens its blooms together, the combined fragrance can be extraordinary, a sweet, complex perfume that seems to rise from the water itself. The flowers create their warmth, as we mentioned before, they're capable of thermogenesis, and on cool nights, you can sometimes see mist rising from the blooms where their heat meets the cooler air, creating an ethereal effect that makes the already magical scene even more dreamlike. Frogs often gather around these flowers, using them as floating platforms, and their evening chorus provides a soundtrack to the visual and olfactory display. Now let's explore one of the most poetic aspects of the night garden, the role of white flowers in folklore and cultural traditions around the world. Across many cultures, white night-blooming flowers have been associated with the spirit world, purity, transitions, and the boundary between life and death. In some Asian traditions, night-blooming jasmine and tuberose are offered at temples and graves, their evening fragrance believed to guide spirits and honor ancestors. In Victorian England, moon gardens planted entirely with white flowers were created as meditation spaces, places where one could walk in the evening and contemplate life's deeper questions while surrounded by pale blooms that seemed to glow with their own light. The Victorians believed that the simplicity of an all-white color palette, combined with the peaceful atmosphere of evening, created ideal conditions for reflection and spiritual connection. Some of these traditional moon gardens still exist, carefully maintained and offering modern visitors the same contemplative experiences their original creators intended. In Mexico, certain white night-blooming flowers are associated with the Day of the Dead celebrations, used to create paths that guide spirits back to visit their living relatives. The flowers' visibility in darkness makes them perfect for this symbolic purpose. They create a luminous pathway that can be followed even on the darkest night. These cultural associations add layers of meaning to our moonlit wanderings, reminding us that humans have been observing and attributing significance to night-blooming flowers for thousands of years, finding in them symbols of transformation, memory, hope, and the enduring cycle of life and death. As we move through a border planted with Nicotiana, we observe how different species in the same genus have evolved slightly different strategies for nighttime success. While all flowering tobaccos intensify their fragrance at night, some species have flowers that remain fully open around the clock, while others close partially during the day and expand fully only at night. Some produce pure white flowers, while others bloom in shades of pink, red, or even lime green. This diversity within a single plant genus demonstrates evolution experimenting with different approaches to the same challenge: how to attract pollinators in darkness. The white-flowered species rely heavily on visual signals enhanced by their reflectivity. The colored varieties may depend more on fragrance, compensating for reduced visibility with increased scent production. Some Nicotianas have flowers with particularly long tubes, restricting access to only the longest-tongued moths, while others have shorter, more open flowers that welcome a variety of visitors. Walking through a diverse planting of Nicotianas on a moonlit night, you can observe these different strategies in action. The white varieties glow brightest, catching your eye first, while the darker-colored flowers reveal themselves primarily through scent, their fragrance announcing their presence before you notice them visually. This diversity ensures that across a range of conditions and pollinator communities, at least some Nicotiana species will successfully reproduce, a botanical insurance policy written in petals and perfume. Finally, as this sixth segment of our wandering approaches its conclusion, let's consider the transformative effect of artificial light on nighttime gardens. While we focused primarily on natural moonlight, many gardens today exist in environments where street lights, security lights, and neighboring buildings contribute to light pollution. This artificial illumination fundamentally changes the nighttime garden experience and affects plant and pollinator behavior in complex ways. Some night-blooming plants actually bloom less reliably or produce less fragrance when exposed to excessive artificial light, their natural rhythms disrupted by illumination that their evolutionary programming doesn't recognize as natural. Certain pollinators, particularly moths, can become disoriented by artificial lights, drawn away from flowers they would otherwise visit. However, artificial light also creates unique opportunities. It can extend viewing hours for night-blooming flowers, allowing people to enjoy them who might not be able to visit during peak moonlit hours. The key is finding balance. Warm-toned, low-intensity lighting placed strategically can enhance a night garden's beauty while minimizing ecological disruption. Lights placed low to illuminate paths while leaving planting beds in natural darkness allow both human enjoyment and normal plant-pollinator interactions. Some gardeners create intentional dark zones in their gardens, areas kept free from artificial light where night-blooming plants and nocturnal creatures can interact without interference, while other sections receive gentle illumination for human use. Standing at the boundary between a lit area and a dark zone in the garden creates a powerful experience. On one side, artificially enhanced visibility and the comfort of light; on the other, the mystery and authentic wildness of true darkness punctuated only by moonlight and starlight. Both experiences have value, and the modern night garden can honor both, creating spaces for different kinds of encounters with the nocturnal world. As you step back from this sixth wandering, perhaps you're beginning to understand that the night garden is not a single, uniform experience but rather a complex tapestry woven from moonlight and dew, from fragrance and silence, from evolutionary adaptation and cultural meaning. Each plant, each droplet, each pollinator visit represents countless generations of refinement, nature solving problems with elegant creativity. In our next segment, we'll explore more unusual night bloomers from around the world, delve into the specific behaviors of nighttime pollinators, and discover how to create your own moon garden designed specifically for nocturnal beauty. For now, rest in the certainty that the garden continues its patient work beneath the stars, blooming and growing, collecting and releasing, in rhythms as old as life itself. We return once more to the moonlit garden, where the night has begun its slow transition toward dawn, though true sunrise remains hours away. The moon hangs lower now, its angle creating dramatic shadows that stretch across the garden like dark rivers flowing between islands of silvered foliage. The dew has reached its maximum accumulation, and every surface glistens as if dusted with crushed diamonds. Let us continue our wandering, discovering yet more secrets hidden in the darkness, more evidence of nature's infinite creativity. Our exploration in this segment begins with one of the most enchanting night bloomers from the tropical regions, the night gladiolus, or Gladiolus tristis, which we touched upon earlier but deserves deeper exploration. What makes this plant particularly fascinating is its ability to produce different fragrances depending on temperature fluctuations throughout the night. As evening falls and the flowers first open, they release a scent dominated by sweet, honeyed notes. But as the night progresses and temperatures drop further, the fragrance composition shifts, with spicy undertones of clove and cinnamon becoming more prominent. This temperature-responsive fragrance modulation occurs because different aromatic compounds have different volatility points. Some evaporate readily at warmer temperatures, while others require cooler conditions to become airborne. The result is that a single flower can present multiple scent personalities over the course of one night, essentially tailoring its advertisement to whichever pollinators are active at different temperature ranges. Early evening moths encounter the sweet, honeyed invitation, while later night visitors find a spicier, more complex offering. For someone sitting in the garden throughout an entire night, perhaps in a comfortable chair with a blanket against the cooling air, the shifting fragrance of night gladiolus provides a natural timekeeper, marking the progression of hours through scent rather than sight. This dynamic quality distinguishes it from flowers that maintain a consistent fragrance, adding an element of temporal variation that makes each hour in the garden a unique sensory experience. The pale yellow flowers seem to capture and concentrate whatever moonlight touches them, creating soft beacons of luminescence that shift subtly in intensity as the moon moves across the sky. As we move along a garden path where stepping stones have been laid, we discover a phenomenon that occurs at the intersection of dew and stone, the creation of dew shadows. Just as solid objects cast shadows in sunlight by blocking light, they also create dew shadows by blocking the radiative cooling that allows dew to form. A stepping stone, retaining heat from the day's sunshine, radiates this warmth upward throughout the night, creating a warm zone above its surface. Plants growing immediately adjacent to the stone, or grass blades arching over it, remain slightly warmer than their counterparts farther away and thus collect less dew or sometimes no dew at all. In bright moonlight, you can observe this pattern. Grass and foliage at a distance from the stones are heavily coated with dewdrops, but immediately around and over each stone, there's a zone of reduced dew formation. The pattern reveals the invisible thermal landscape of the garden, showing how heat moves and lingers in ways our eyes cannot detect but that dew makes visible. This principle applies to walls, boulders, and even tree trunks. Any mass that absorbs heat during the day and releases it slowly at night creates a microclimate around itself. Observing these dew patterns can teach you about the thermal geography of your garden, information that can inform planting decisions. Heat-loving plants might thrive in these warmer zones near thermal masses, while moisture lovers would prefer the cooler areas where dew forms most heavily. The garden reveals its secrets to those patient enough to observe. Now let's explore one of the most dramatic night bloomers from Central and South America, the night-blooming cactus called Selanisarius grandiflorus, often known as the Queen of the Night or vanilla cactus. This sprawling, vine-like cactus produces flowers that are among the most spectacular in the entire cactus family. Blooms can reach up to 12 inches in diameter, with long, narrow outer petals in shades of gold, yellow, or bronze, and inner petals of pure, luminous white surrounding a center filled with hundreds of creamy yellow stamens. The flower's structure is architecturally complex, with layers upon layers of petals creating depth and dimension that seem almost sculptural. What makes Selanisarius grandiflorus particularly legendary is its fragrance, a powerful, intoxicating perfume that combines vanilla, jasmine, and exotic spices in a blend so rich and complex that people have struggled for centuries to adequately describe it. The scent is so potent that a single flower can perfume an entire house if brought indoors, or fill a large section of garden if grown outdoors. The vanilla cactus flower opens only once, beginning its unfurling process around sunset and reaching full magnificence by midnight. By the following morning, the flower has collapsed and withered, its brief moment of glory complete. This ephemeral nature has made witnessing a Selanisarius grandiflorus bloom something of a horticultural event. Collectors who grow these cacti often invite friends and family to bloom parties when they detect that a flower is ready to open. Guests gather in the evening, perhaps sharing food and conversation, while periodically checking the bud's progress. As the flower opens, conversation often quiets, everyone transfixed by the slow unfurling of petals and the gradually intensifying fragrance. There's something almost spiritual about this shared witness to such fleeting beauty, a reminder of life's precious impermanence. The flower seems to glow in moonlight, its white inner petals reflecting lunar rays while the outer petals create a golden halo around this radiant center. By dawn, those who stayed to watch the flower through the night witness its collapse, the petals growing limp, the vibrant structure softening and drooping. It's both melancholy and beautiful, a complete life cycle compressed into a single night. As we pause beside a planting of Dame's rocket, Hesperis matronalis, we encounter a flower that demonstrates the importance of common names in revealing plant characteristics. Hesperis comes from the Greek word for evening, and rocket refers to the plant's relation to mustards and other members of the Brassicaceae family. Dame's rocket produces clusters of four-petaled flowers in shades of purple, pink, or white that remain open during the day but dramatically intensify their fragrance as evening approaches. The scent is sweet and penetrating, reminiscent of garden phlox but with additional complexity, notes of clove and a slight spiciness that gives depth to the basic sweetness. What's particularly interesting about Dame's rocket is its biennial life cycle and its ability to naturalize in gardens and wild areas. A plant that blooms one year will set seed and die, but those seeds germinate and grow, creating new plants that bloom in subsequent years. Over time, a single planting can spread and establish itself across a wide area, creating drifts of evening fragrance that seem to appear spontaneously in unexpected locations. In moonlight, the pale-flowered varieties of Dame's rocket create a soft glow among darker foliage, their four-petaled blooms simple in structure but charming in their unpretentious beauty. The flowers attract a wide variety of moths, and on a warm evening, you might see dozens of these nocturnal visitors moving from flower to flower, their wings catching moonlight in brief flashes of reflected silver. Dame's rocket has naturalized so successfully in parts of North America that some consider it invasive, but in appropriate settings, its evening fragrance and easy cultivation make it a valuable addition to the night garden. The dew that forms on its slightly hairy leaves and stems creates a fuzzy, sparkling effect, as if the entire plant has been outlined in luminescent thread. Continuing our wandering, we discover a fascinating aspect of nocturnal plant defense, the changes some plants undergo at night to protect themselves. Certain plants close their leaves or flowers not just to conserve moisture or regulate temperature, but to protect vulnerable new growth or developing seeds from nocturnal herbivores. Some plants produce defensive chemicals that are more concentrated at night when slug and snail activity peaks. Others rely on physical barriers, leaves that curl or fold to make themselves less accessible or appealing to night-feeding insects. One particularly clever strategy involves the production of sticky or tacky substances on leaf surfaces that intensify after dark. These natural adhesives trap small insects that might otherwise feed on the plant, essentially turning the leaf surface into a passive trap. In heavy dew conditions, these sticky surfaces become even more effective as the moisture helps spread the adhesive compounds and makes it harder for trapped insects to escape. Walking through the garden and gently touching various leaves, you might notice that some have a slightly sticky or tacky feel at night that isn't present during the day, evidence of these defensive secretions at work. The interplay between plants defending themselves and herbivores attempting to feed creates a nocturnal arms race playing out in miniature all around the garden. Some caterpillars and beetles have evolved to feed specifically at night when defensive compounds are less concentrated. In response, some plants have evolved the opposite strategy, increasing defenses at night. This evolutionary back and forth has been ongoing for millions of years, with neither side achieving permanent victory, only temporary advantages that shift back and forth across generations. As we venture near a bed of moonflowers in full glory, we observe a phenomenon that becomes apparent only through extended observation, the subtle movement of flowers tracking the moon's path across the sky. We mentioned selenotropism earlier, but witnessing it in real time requires patience. If you mark the position of a moonflower bloom against a fixed background, perhaps a fence post or tree trunk, and then return to check its orientation an hour or two later, you may notice it has shifted slightly. The movement is subtle, nothing like the dramatic tracking of sunflowers following the sun, but it's measurable and meaningful. The flower maintains an orientation that maximizes the amount of moonlight falling directly into its funnel-shaped bloom, ensuring that the white petals reflect as much light as possible toward approaching pollinators. This movement is controlled by differential growth rates on opposite sides of the flower stem. The side away from the moon grows slightly faster, pushing the flower head to turn toward the light source. What makes this particularly remarkable is that moonlight is approximately 400,000 times dimmer than direct sunlight, yet the plant's photoreceptor systems are sensitive enough to detect and respond to this faint illumination. It's equivalent to a human being able to navigate by the light of a single candle hundreds of feet away, a level of sensitivity that seems almost impossible, yet the plant achieves it routinely, night after night. Observing this subtle tracking behavior creates a sense of communion with the plant, an awareness that it's actively responding to the same moonlight you're enjoying, that you and the flower are both participants in this nocturnal dance rather than just observer and observed. Now let's explore one of the most unusual night bloomers from the succulent world, the night-blooming cereus species Epiphyllum hookeri, which produces flowers with an almost alien appearance. The blooms are large, often 8 to 10 inches across, with numerous narrow, pointed petals that radiate outward from the center like the rays of a stylized sun. The outer petals are often tinged with green or bronze, while the inner petals are pure white, creating a gradation of color from warm earth tones to cool lunar white. What distinguishes Epiphyllum hookeri from other night-blooming cereus species is the unusual structure of its reproductive parts. The stamens and pistil extend far beyond the petals, creating a projecting bundle that looks almost like an elaborate tassel or firework frozen in mid-burst. This extension serves a practical purpose. It positions the pollen-bearing anthers and the pollen-receiving stigma at just the right height for contact with the bodies of visiting hawk moths, ensuring efficient pollen transfer. The fragrance is sweet but with an unexpected sour note, reminiscent of citrus mixed with vanilla and something slightly fermented. This complex scent profile attracts a specific community of pollinators that might ignore simpler, purely sweet fragrances. In Moonlight, the flower's elaborate structure creates complex shadows and highlights, depth and dimension that make it look three-dimensional in a way that photographs can never quite capture. You need to see it in person, ideally with natural moonlight creating the interplay of light and shadow, to fully appreciate its alien beauty. The flower seems to belong to some other world, some exotic realm where evolution took different turns and arrived at different solutions to the same basic challenges. As we pause near a water feature once again, we observe how the sound of moving water affects our perception of the nighttime garden. The splashing or trickling of a fountain or waterfall creates a sonic environment that masks more distant sounds, traffic noise, neighboring activities, while allowing nearer sounds to remain audible. This selective acoustic filtering creates an envelope of tranquility, making the garden feel more isolated and private than it actually is. The sound of water also harmonizes with other night sounds, cricket chirps, frog calls, the rustle of leaves in evening breezes, creating a layered soundscape that's simultaneously relaxing and engaging. Research has shown that the sound of moving water can lower blood pressure, reduce stress hormones, and promote the kind of relaxed alertness ideal for contemplation and observation. In the night garden, where our visual sense is diminished, our hearing becomes more acute, and the sonic environment becomes a crucial part of the overall experience. The presence of water also affects how fragrance behaves in the garden. Moisture in the air around a water feature helps carry scent molecules farther and more effectively than dry air, extending the range of night-blooming flowers' fragrances. The combination of enhanced scent distribution and sonic masking creates an almost magical atmosphere. You're wrapped in layers of fragrance while the sound of water creates a peaceful foundation for the entire experience. This is why traditional moon gardens and contemplative spaces often incorporated water features as essential elements rather than mere decoration. Finally, as this seventh segment of our wandering draws toward its close, let's consider the role of nocturnal birds in the night garden ecosystem. While we've focused primarily on insects as pollinators, certain regions host night-active birds that play important roles in nighttime gardens. Nightingales, famous for their elaborate nocturnal songs, feed on insects attracted to night-blooming flowers, creating an indirect relationship between the birds and the blooms. In tropical and subtropical regions, nightjars and related species hawk for insects around flowering plants, while some hummingbird species in the Americas are crepuscular, remaining active in the deep twilight hours and even visiting flowers in near darkness. The songs and calls of these nocturnal birds add another dimension to the nighttime garden experience, melodic layers that weave through the fragrance and visual beauty. Some night-singing birds time their performances to coincide with peak moonlight hours, their songs carrying farther in the still, cool air. The nightingale's song in particular has inspired countless poets and writers throughout history, its elaborate trills and variations seeming almost impossibly complex for a bird to produce. Hearing a nightingale singing in a moon garden filled with white flowers and sweet fragrances creates an experience that transcends mere sensory pleasure and approaches something spiritual, a moment of perfect synthesis between sight, scent, and sound, between the natural world and human appreciation of it. As you prepare to leave this seventh wandering, carry with you the awareness that the night garden operates on multiple levels simultaneously: chemical and visual, tactile and sonic, practical and aesthetic. Every element serves purposes both functional and beautiful, often inseparably combined. The fragrance that delights us exists to attract pollinators. The dew that sparkles so beautifully also provides essential moisture. The moonlight that creates such magical visual effects also guides pollinators and influences plant behavior. Nothing here is purely ornamental, everything serves life's continuation while also creating beauty that invites our wonder and contemplation. In our next segment, we'll explore more about seasonal variations in the night garden, specific techniques for creating moon gardens of your own, and some of the rarest night-blooming species from remote corners of the world. For now, rest peacefully, knowing the garden continues its patient work beneath the wheeling stars. We gather ourselves once more for another journey into the moonlit garden, where the night has reached that liminal space between its deepest hour and the first whispers of approaching dawn. The air has taken on a particular quality, cool and crystalline, carrying scents with extraordinary clarity. The moon, now descending toward the western horizon, casts its light at increasingly acute angles, creating shadows so long they seem to stretch toward infinity. Let us continue our wandering through this realm where darkness reveals rather than conceals, where night itself becomes a canvas for nature's artistry. Our exploration in this segment begins with one of the most mysterious night bloomers from the orchid family, the night-scented orchid, Platanthera bifolia, a terrestrial species native to European meadows and woodlands. Unlike the tropical orchids that capture most gardeners' attention, this modest plant produces slender spikes of small, greenish-white flowers that would be easy to overlook in daylight. But as evening falls, these unassuming blooms undergo a dramatic transformation in their scent production, releasing one of the most powerful and far-reaching fragrances in the entire orchid family. The perfume has been described as intensely sweet with undertones of vanilla and clove, reminiscent of carnations but more complex and penetrating. A single spike of flowers can perfume an area the size of a tennis court, the scent carrying on the slightest breeze to distances that seem impossible for such small blooms. What makes this orchid particularly fascinating is the precision of its fragrance timing. The scent production begins precisely at dusk, reaches peak intensity around midnight, and then gradually diminishes toward dawn, following a pattern so regular you could use it as a timepiece. This timing corresponds exactly with the activity patterns of the orchid's primary pollinators, specific species of noctuid moths that emerge at dusk, feed throughout the night, and return to rest as dawn approaches. The orchid has calibrated its entire reproductive strategy around these moths' schedule, investing energy in fragrance production only during the hours when it will be most effective. In moonlit meadows where these orchids grow wild, the sight of dozens or hundreds of flower spikes standing like pale candles, each one broadcasting its invisible invitation into the darkness, creates an atmosphere of profound natural magic. The moths arrive as if summoned, their antennae detecting fragrance molecules from remarkable distances, drawn inexorably to these modest flowers that have evolved specifically to entrance them. As we move through a section of the garden where ferns grow in shaded areas, we discover a fascinating aspect of how these ancient plants interact with dew. Ferns, lacking flowers entirely and reproducing through spores rather than seeds, have evolved intricate leaf structures that manage moisture in sophisticated ways. Many fern species have leaves covered with microscopic scales or hairs that create a water-repellent surface, causing dew to bead up rather than spread across the leaf. This hydrophobic quality serves multiple purposes. It prevents water from blocking the tiny pores through which ferns breathe, it helps shed excess moisture that might promote fungal growth, and it creates stunning visual effects in moonlight. A fern frond covered in perfectly spherical dewdrops becomes a work of natural jewelry, each droplet sitting atop the leaf surface like a pearl on green velvet. The compound structure of fern leaves, the way they're divided and subdivided into countless small leaflets, creates an almost fractal pattern of dew accumulation, with droplets forming at regular intervals along the leaf architecture. Observing ferns in moonlight reveals the elegance of their structure in ways that daylight viewing often misses. The backlighting effect of moonlight shining through the delicate leaflets, combined with the sparkle of dew on the leaf surfaces, transforms these ancient plants into ethereal sculptures. Some fern species also exhibit a subtle movement at night, their fronds adjusting position slightly to minimize heat loss or optimize moisture retention. This movement is so slow as to be imperceptible in real time, but time-lapse photography reveals fern fronds slowly curling and adjusting throughout the night, responding to temperature and humidity changes with surprising dynamism. Now let's explore one of the most spectacular night bloomers from the tropical Americas, the sacred Datura wrightii, a plant that produces enormous trumpet-shaped flowers that can measure up to 8 inches in length and equally wide at the opening. These magnificent white blooms begin opening in late afternoon, their unfurling accelerating as darkness falls, and by full nightfall they're completely open, their trumpets flared wide to receive visiting hawk moths. The sacred datura's fragrance is powerful and sweet, with a slightly intoxicating quality that seems fitting given the plant's long history of use in spiritual ceremonies and shamanic practices, though it should be noted that all parts of datura plants are highly toxic and should never be ingested. The flowers produce copious nectar, and their structure creates a perfect landing platform for large hawk moths. The white petals seem to amplify whatever light touches them, glowing with unusual intensity in moonlight and creating the impression of luminous bells floating in darkness. What makes sacred datura particularly interesting from a botanical perspective is its seed dispersal strategy, which connects back to its nighttime flowering. The flowers, once pollinated, develop into spiky, spherical seed pods that eventually dry and split open. These pods are covered in sharp thorns that catch on the fur of animals, including deer, coyotes, and other mammals active during dawn and dusk hours when these animals move through datura growing areas. The seeds are dispersed when the pods break apart or when animals brush against them, carrying the spiky capsules to new locations. Thus the plant's reproductive cycle involves both nocturnal pollinators and crepuscular seed dispersers, taking advantage of different communities of creatures active at different times. In gardens where sacred datura grows, the sight of multiple flowers opening on a warm evening creates a spectacular display, dozens of white trumpets unfurling simultaneously, their collective fragrance almost overwhelming in intensity. By morning, the flowers have usually collapsed and wilted, though on cool days they may persist until midday before finally succumbing. Each flower's brief glory is intense but fleeting, a pattern we've seen repeated across so many night bloomers, this investment of tremendous energy for a single night's opportunity at pollination. As we continue our wandering and pause beside a patch of white clover, we discover that even this humble plant has nocturnal secrets. White clover, usually dismissed as merely a lawn plant or pasture forage, produces small white flowers that intensify their fragrance at night, releasing a sweet, honey-like perfume that attracts night-flying insects. The individual flowers are tiny, but clover typically grows in patches containing hundreds or thousands of blooms, and the collective fragrance can be surprisingly strong. What's particularly interesting about clover is how it adjusts its flowering based on mowing or grazing pressure. When frequently cut or grazed, clover plants produce flowers on very short stems, keeping them below the cutting height and ensuring they can still reproduce. When left undisturbed, the flower stems grow taller, raising the blooms higher above the foliage. This adaptability has allowed clover to thrive in managed landscapes while maintaining its reproductive success. At night, these flowers collect dew heavily, and each three-part leaf becomes a perfect platform for a large, central dewdrop with smaller droplets arrayed around it. The symmetry of dew formation on clover leaves, typically 3 droplets arranged in a triangle with a larger central drop, creates remarkably consistent patterns across thousands of leaves. In bright moonlight, a clover patch becomes a field of sparkling geometry, each leaf contributing its small portion to an overall effect of scattered brilliance. Rabbits and deer often feed on clover during nighttime hours, drawn by both the nutritious foliage and the moisture provided by accumulated dew. Observing these animals feeding in moonlight, moving slowly through the clover while dew sparkles around them, connects us to patterns of behavior that have existed for thousands of years, long before humans cultivated gardens. Continuing our exploration, we encounter a phenomenon that occurs in gardens with varied topography, the creation of cold air pockets and dew rivers. Cold air, being denser than warm air, flows downhill like an invisible liquid, pooling in low spots and creating temperature variations of several degrees within small areas. These cold pockets experience heavier dew formation because the cooler temperatures cause surfaces to reach the dew point earlier and remain below it longer. On sloping ground, you can sometimes observe what looks like a river of extra heavy dew flowing down a gentle incline, not actual flowing water, but a band of particularly heavy dew formation following the path of cold air drainage. Plants growing in these dew rivers remain wet longer into the morning than those on higher ground. This creates microhabitats within the garden where moisture-loving plants can thrive even in generally drier conditions. Understanding these patterns of cold air drainage and dew accumulation allows gardeners to match plants to microsites more effectively, placing moisture lovers in the dew rivers and heat lovers on the warmer high points. These temperature variations also affect night-blooming flowers. Plants in cold pockets may delay their opening slightly, waiting for temperatures to rise enough to facilitate the petal movement required for blooming. Conversely, flowers in warmer microclimates may open earlier and more enthusiastically. The garden's thermal landscape, invisible to our eyes but made partially visible through patterns of dew, creates a complex three-dimensional environment where temperature, moisture, and altitude interact to create countless unique growing conditions within even a small space. As we venture near a stand of evening primrose, we witness another remarkable aspect of these plants, their ability to detect and respond to the approach of pollinators even before contact occurs. Research has shown that evening primrose flowers can sense the electrical fields generated by flying insects, particularly bees and moths, and respond by rapidly increasing their nectar sugar concentration within minutes of detecting a potential visitor's approach. This almost seems like science fiction, yet it's real and measurable. The flowers essentially know when pollinators are nearby and sweeten their nectar to make themselves more attractive, increasing the chances the approaching insect will choose to visit rather than passing by. The mechanism involves specialized cells that detect the minute electrical charges carried by flying insects, charges created by friction between the insect's body and the air molecules it moves through. When these charges are detected, the flower initiates a cascade of chemical reactions that rapidly convert stored starches into sugars and moves these sugars into the nectar. This responsiveness demonstrates a level of plant awareness and real-time decision-making that challenges our traditional understanding of plants as passive, unaware organisms. The evening primrose is actively monitoring its environment, detecting the presence of other living things, and adjusting its chemistry in response, all without a brain or nervous system as we understand them. Observing these flowers in a moonlit garden, knowing that they're continuously sensing and responding to the approach of moths you can barely see, adds another layer of wonder to the experience. The garden isn't just beautiful, it's intelligent in ways we're only beginning to understand. Now let's explore one of the most fragrant night bloomers from the shrub world, the night jasmine or Cestrum nocturnum, which we touched upon in an earlier segment but deserves deeper consideration. While many night fragrant plants produce scents that dissipate within a certain radius, night jasmine's fragrance has an almost supernatural ability to travel. In still air, the scent can carry several hundred feet from a single plant. When gentle breezes are blowing, the fragrance has been detected at distances exceeding a quarter mile. This extraordinary scent projection occurs because the flowers produce their fragrance compounds in a particularly volatile form or molecular structures that readily evaporate and remain airborne for extended periods. The fragrance molecules are also produced in tremendous quantities. A single flowering branch can release enough scent compounds in one night to be measured in milligrams, a tiny amount by human standards but astronomical on a molecular level. What's particularly interesting is how the fragrance behaves in layered air conditions. On calm nights when air stratifies into layers of different temperatures, the scent can travel horizontally along a specific temperature layer, creating a phenomenon where the fragrance might be very strong at ground level but almost undetectable at head height, or vice versa. As we pause near a bed of white petunias again, we observe how these common flowers demonstrate an interesting relationship between flower size and fragrance intensity. Individual petunia flowers are relatively small, typically 2 to 3 inches across, yet they produce fragrance levels comparable to much larger blooms. This occurs because fragrance production is less about flower size than about the density of specialized scent-producing cells in the petal tissues. Petunias pack these scent cells densely into their relatively small petals, creating an efficient fragrance production system. This efficiency means that a small plant covered in blooms can produce as much total fragrance as a much larger plant with fewer flowers. For gardeners working with limited space, this makes white petunias an excellent choice for moon gardens. They provide substantial visual impact through their white color and prolific blooming, plus significant fragrance contribution, all from relatively compact plants. The fragrance also has a pleasant quality that most people find appealing without being overwhelming, unlike some night bloomers whose scents can be almost aggressively intense. In moonlight, masses of white petunias create a luminous carpet or cascading effect if grown in hanging baskets, their blooms so numerous they almost obscure the foliage. Dew settles into the trumpet-shaped flowers, creating small pools of water that reflect moonlight, adding to the overall effect of shimmering luminosity. Moths visit these flowers throughout the night, and if you watch carefully, you can observe their feeding behavior, the way they hover briefly, extend their proboscis into the flower's throat, feed for a few seconds, then move to the next bloom. The entire interaction takes only moments, yet it represents the continuation of a relationship millions of years old, plant and pollinator locked in an evolutionary partnership from which both benefit. Finally, as this 8th segment of our wandering approaches its conclusion, let's consider the phenomenon of nocturnal photosynthesis in certain specialized plants. While most plants conduct photosynthesis only during daylight hours, some desert-adapted plants, particularly certain cacti and succulents, have evolved a modified photosynthetic pathway called CAM, crassulacean acid metabolism, that allows them to open their stomata and absorb carbon dioxide primarily at night. During the cool nighttime hours, these plants open their pores and take in carbon dioxide, which they store in the form of organic acids. During the day, when heat and aridity would make opening stomata wasteful because of excessive water loss, they keep their pores closed and use the stored carbon dioxide for photosynthesis. This strategy allows them to survive in extremely arid environments where conventional photosynthesis would be impossible. What's remarkable is that this process occurs silently and invisibly, the plant breathing in darkness, storing what it needs for the day to come. Some CAM plants also produce visible dew, not just passively collecting it from the air but actually releasing moisture through their tissues at night. This internal moisture, transported from deep roots to surface tissues, condenses on the cooler night air, creating the paradoxical sight of a desert plant covered in dew despite the arid environment. This self-generated dew provides moisture for the plant's own epidermal cells and can also support small insects and other creatures that depend on dew for hydration. The plant becomes a water source in the desert night, a living spring that refreshes itself and others through its unique metabolic adaptations. As you prepare to leave this 8th wandering, carry with you the understanding that the night garden operates on principles both familiar and strange. Some aspects mirror daytime garden ecology, pollination, growth, moisture management, but executed with nocturnal variations. Other aspects are entirely unique to nighttime, occurring only in darkness or depending on properties of moonlight and dew that have no daytime equivalents. The night garden isn't merely the day garden with the lights turned down, it's a fundamentally different ecosystem, governed by different rules and populated by different communities of creatures. The flowers that bloom here have chosen darkness for specific reasons, and their adaptations, visual, chemical, structural, represent elegant solutions to the challenges darkness presents. In our next segment, we'll explore more about creating moon gardens intentionally, the specific needs of different night bloomers, and some final remarkable species from the world's most remote and exotic locations. For now, rest peacefully, knowing that the garden continues its silent work beneath the ancient light of moon and stars. We return once more to the moonlit garden, where the night has begun its gentle surrender to the approaching dawn, though the sky remains dark and star-filled. The moon, now low on the western horizon, casts its light in elongated golden tones, different from the silvery illumination of its higher arc. The garden holds a particular stillness at this hour, as if gathering itself for the transition to come. Yet there remain wonders to discover, secrets that reveal themselves only in these final hours of darkness. Let us continue our wandering, savoring these last moments before daylight reclaims the landscape. Our exploration in this segment begins with one of the most unusual night bloomers from the passion flower family, the bat-pollinated passion flower, Passiflora mucronata, a species from the cloud forests of Central and South America. Unlike its day-blooming cousins that produce colorful displays to attract bees and butterflies, this remarkable species has evolved flowers specifically designed for bat pollination. The blooms are greenish-white to pale yellow, colors that show up reasonably well in low light but aren't particularly vivid. What makes these flowers extraordinary is their structure. They produce numerous long, dangling stamens that hang below the flower like a fringe or beard, extending sometimes 6 inches or more. This arrangement serves a specific purpose. When bats approach to feed on the copious nectar, their furry heads and bodies brush against these hanging stamens, coating themselves with pollen. The bats, hovering with their characteristic erratic flight, move from flower to flower throughout the night, inadvertently providing pollination services while feeding. The flowers produce a musky, slightly fermented scent quite different from the sweet fragrances we associate with most night bloomers, a scent that appeals specifically to fruit bats and nectar bats rather than moths or beetles. In their native cloud forests, these passion flowers bloom during seasons when fruit is scarce, providing critical nutrition for bat populations that would otherwise struggle to find food. The relationship is mutualistic in the deepest sense. The plant depends entirely on bats for pollination, while the bats depend on the flowers for survival during lean times. Observing these flowers in a moonlit garden, their strange fringe of stamen swaying in evening breezes, creates an impression of alien beauty, as if evolution took a completely different path in designing this particular solution to the pollination challenge. As we move along a garden border where shrubs create structure and definition, we discover how woody plants interact with dew in ways distinct from herbaceous plants. Bark, being rough and textured, provides tremendous surface area for dew formation. A single branch might accumulate hundreds of tiny droplets in every crevice and texture variation of its bark. As these droplets grow and merge, they eventually become heavy enough to fall, creating a miniature rain beneath the shrub or tree. This phenomenon is called throughfall, and it can deliver significantly more water to the ground beneath a tree than falls in open areas from dew alone. The bark essentially acts as a collection and concentration system, harvesting dew from a large 3-dimensional area and funneling it downward. Plants growing beneath trees and shrubs benefit from this additional moisture, receiving water even on nights when dew formation in open areas is minimal. This creates another microhabitat in the garden, the understory zone where shade combines with enhanced moisture to create conditions quite different from open garden beds. In moonlight, dew-covered bark takes on a different character than dew on leaves or petals. The droplets are smaller and more numerous, creating a subtle sparkle rather than distinct points of light. The bark appears to shimmer, taking on a slight luminescence as thousands of microdroplets catch and reflect available light. Old, deeply textured bark creates the most dramatic effects, with moisture accumulating in deep fissures and creating patterns that reveal the tree's growth history written in water and light. Running your hand along dew-covered bark in darkness connects you to the tree's surface in a tactile way that daylight observation rarely provides. You feel the texture, the moisture, the living architecture that usually registers only visually. Now let's explore one of the most fragrant night bloomers from the lily family, the Turk's cap lily, Lilium martagon, particularly the white-flowered varieties. These elegant lilies produce downward-facing flowers with strongly recurved petals that curl back upon themselves, creating a distinctive turban or cap shape that gives the plant its common name. The flowers are typically pink or purple, but the white forms are especially valued for moon gardens, their pale blooms visible in even dim light. What makes Turk's cap lilies particularly interesting is their fragrance progression throughout their blooming period. When flowers first open, the scent is relatively mild, pleasant but not overwhelming. As the flowers mature over several days, the fragrance intensifies significantly, and it shifts towards stronger night production. By the time the flowers are fully mature, just before pollen release, the nighttime fragrance can be remarkably powerful, sweet with spicy undertones reminiscent of carnations mixed with exotic incense. This fragrance intensification serves a specific purpose, attracting pollinators during the critical window when the flowers are most receptive and pollen is most viable. The timing ensures that pollinator visits occur at optimal moments for successful fertilization. In traditional cottage gardens, Turk's cap lilies were often planted near windows and doorways, their fragrance drifting indoors on summer evenings. The downward-facing flowers also create an interesting interaction with dew. The recurved petals form small channels that guide water droplets toward the petal tips, where they accumulate into larger drops that eventually fall, creating a gentle dripping sound on quiet nights. This acoustic dimension adds to the sensory richness of the night garden experience. As we continue our wandering and pause beside a collection of succulents, we discover how these water-storing plants create their own microclimates. Succulent leaves, being thick and fleshy, heat up significantly during sunny days, absorbing and storing thermal energy. At night, this stored heat releases slowly, creating a warm zone around the plants. This warmth affects dew formation in complex ways. The succulent leaves themselves remain too warm to collect dew for several hours after sunset, but the ground around them cools normally. This creates a pattern where the soil surface and any low-growing plants near the succulents collect heavy dew, while the succulents themselves remain dry. As the night progresses and the succulents finally cool to dew point temperature, condensation begins, but by then the surrounding ground may be saturated, creating a temporal sequence of dew formation that moves through the area in waves. Some succulents also exhibit an interesting behavior at night. Their leaves shift position slightly, moving to minimize their surface area exposed to the night sky, reducing heat loss and conserving the energy they'll need for the next day's photosynthesis. This movement is subtle, a matter of a few degrees of adjustment, but measurable and purposeful. The plants are actively managing their thermal budget, making decisions about energy conservation versus moisture collection. In bright moonlight, the fleshy leaves of succulents often take on an almost translucent quality, light penetrating the outer cell layers and revealing the internal structure. Some succulents appear to glow from within, their stored water and light-colored interior tissues creating a lantern-like effect. Continuing our exploration, we encounter one of the most powerfully fragrant night bloomers from the Mediterranean region, the white tobacco plant, Nicotiana sylvestris. This tall, stately plant can reach 4 to 5 feet in height, topped with long, tubular white flowers that hang in graceful clusters. Unlike some of its shorter cousins in the Nicotiana genus, this species produces flowers with tubes that can extend 4 to 5 inches in length, creating elegant, pendulous shapes that sway gently in evening breezes. The fragrance is extraordinary, intensely sweet with a slight spicy undertone, powerful enough that a single plant can perfume a large area. What's particularly interesting about Nicotiana sylvestris is the precision of its fragrance release. The scent production begins exactly at sunset, triggered not by darkness alone but by the specific combination of decreasing light and cooling temperature that signals day's end. Within 15 to 20 minutes of this trigger, the fragrance intensifies from barely noticeable to powerfully present, as if someone turned a dial from 0 to maximum. This rapid onset ensures that the flowers are advertising at full strength during the critical early evening hours when hawk moths first emerge and begin seeking food sources. The long, narrow flower tubes exclude all but the longest-tongued pollinators, ensuring that only the most effective visitors, those that will travel long distances and visit many flowers, receive the nectar reward. In moonlight, the white flowers appear to float above the large, velvety leaves, creating the impression of a constellation of stars brought down to earth level. The flowers produce so much nectar that on humid nights, you can sometimes see droplets forming at the tube openings, glistening like liquid silver in the lunar glow. As we venture near a stone wall or rock garden feature, we discover how stones and rocks create unique thermal environments that affect both plants and dew formation. Large rocks absorb tremendous amounts of heat during sunny days, storing this thermal energy deep within their mass. At night, while surfaces cool rapidly, the interior of large rocks remains warm for hours, releasing heat slowly to the surrounding area. This creates a warm microclimate in the immediate vicinity of rocks, where temperatures may be several degrees higher than just a few feet away. Plants growing in rock crevices benefit from this warmth, experiencing less extreme temperature swings than those in open ground. However, this warmth also affects dew formation. Surfaces immediately adjacent to warm rocks may remain above the dew point all night, staying dry while surrounding areas collect heavy moisture. This creates a patchwork of wet and dry zones, visible in moonlight as areas of sparkle interspersed with darker, dew-free patches. The rocks themselves, depending on their surface texture, may collect dew in interesting patterns. Smooth, polished rocks shed water quickly, droplets sliding off under their own weight. Rough, porous rocks absorb water into their surface texture, appearing to darken as they collect moisture. Some rocks, particularly those with crystalline components, create spectacular effects in moonlight when covered with dew. The moisture magnifies the natural sparkle of crystal inclusions, creating points of brilliant reflection scattered across the rock surface. Traditional Japanese gardens understood these principles, carefully selecting and positioning rocks not just for their daytime appearance but for the way they would interact with moonlight and dew. Now let's explore one of the most mysterious night bloomers from the American Southwest, the queen of the night cactus that grows on rocky hillsides, Piniocereus greggi. This plant is remarkable for being nearly invisible for most of its life. The stems are thin and gray-green, barely thicker than pencils, and during the day they're almost indistinguishable from dead twigs and branches among which they grow. The plant can exist for years, even decades, slowly developing a massive underground storage root that can weigh 50 pounds or more, while the above-ground portions remain modest and camouflaged. But on a few nights each year, usually in late June or early July, often coinciding with periods near the full moon, these inconspicuous stems produce flowers of breathtaking beauty. The blooms can measure 6 to 8 inches across, with layers of pure white petals surrounding a center filled with creamy yellow stamens. The flowers open after sunset and remain open only until the following morning, wilting as sunlight strengthens. The fragrance is powerful and sweet, reminiscent of vanilla with undertones of jasmine, capable of traveling hundreds of feet on desert breezes. What makes Piniocereus greggi particularly fascinating is that all the plants in a given area tend to bloom on the same night, creating a synchronized flowering event that attracts every hawk moth within range. The selective pressure favoring synchronized blooming is clear. A single plant blooming alone might be missed by passing moths, but dozens or hundreds blooming simultaneously create an olfactory beacon impossible to ignore, ensuring successful pollination for the entire population. Native Americans in the Southwest learned to watch for these blooming events, considering them special occasions worthy of gathering and celebration. The sight of a moonlit desert hillside suddenly dotted with large white flowers where none were visible the day before creates an almost mystical experience, as if the landscape itself has transformed overnight. As we pause beside a bed of white cosmos, we observe how these common annuals demonstrate the principle that night beauty isn't limited to exotic or rare species. Cosmos, with their simple daisy-like flowers and delicate, feathery foliage, are staples of summer gardens, valued for their easy cultivation and prolific blooming. White varieties, while lovely in daylight, take on special character at night. The flowers seem to glow with unusual intensity in moonlight, their simple form and pure color making them highly visible even in dim conditions. The petals, while appearing solid white in daylight, actually have a slightly translucent quality that becomes apparent in moonlight. Light passes through the petal tissue, creating a soft luminescence quite different from the opaque reflectivity of some other white flowers. The feathery foliage collects dew in interesting patterns, water droplets forming along the fine leaf divisions like beads on thread, creating a sparkling network that catches light from multiple angles. Cosmos flowers don't intensify their fragrance at night, they produce only a faint, sweet scent, but they compensate with their visual presence and their ability to move gracefully in evening breezes. The flowers, borne on long, slender stems, sway and dance with the slightest air movement, creating a kinetic dimension that's particularly noticeable in low light when your eyes track movement more readily than static objects. A bed of white cosmos in moonlight becomes a flowing, undulating sea of pale blooms, constantly shifting and changing, never quite still. Finally, as this 9th segment of our wandering approaches its conclusion, let's consider the phenomenon of morning dew evaporation and how it creates a final moment of beauty before the night garden yields to day. As the sun rises and its warmth begins to reach the garden, dew doesn't simply disappear, it evaporates gradually, creating rising mist and vapor that becomes visible when illuminated by low-angle morning sunlight. This morning mist, sometimes called ground fog, creates an ethereal effect where the garden seems to float in a sea of soft white vapor. The mist forms most densely in areas where dew was heaviest, low spots where cold air pooled, areas with dense vegetation, places near water features. The rising vapor carries with it the scents of the garden, lifting the fragrances of soil, foliage, and any remaining night-blooming flowers into the air, creating a final olfactory symphony that marks the transition from night to day. This liminal period, when moonlight and sunlight coexist, when night bloomers begin to close while day bloomers prepare to open, when dew transforms from liquid to vapor, has a quality unlike any other time in the garden. It's neither fully night nor fully day but rather a threshold space where both realms overlap. Standing in a garden during this transition, watching vapor rise through slanting sunlight while the moon still hangs pale in the western sky, you experience a moment of perfect balance, a reminder that nature operates not in discrete categories but in continuous gradients, each state flowing into the next without hard boundaries. As you prepare to leave this 9th wandering, carry with you the awareness that the night garden's influence extends even into the daylight hours. The pollination accomplished during darkness will produce seeds and fruits that feed creatures active during the day. The moisture collected as dew will sustain plants through the coming heat. The beauty witnessed under moonlight will linger in memory, informing how you see the garden even when sun illuminates every corner. The night garden and the day garden aren't separate entities but rather two aspects of a continuous whole, each contributing to the other, each incomplete without the other. In our final segment, we'll bring together all we've learned, exploring how to create moon gardens of your own and reflecting on the deeper meanings that nocturnal wanderings can offer. For now, rest peacefully, knowing that the garden transitions from darkness to light with the same grace it showed moving from light to darkness, patient and purposeful in all its transformations. We gather ourselves one final time for our last journey into the moonlit garden, where the night has reached its most poignant hour, that precious time when darkness still holds dominion, yet the first whispers of dawn tremble at the edge of awareness. The moon, now a pale ghost low on the western horizon, casts its last golden rays across a garden transformed by our many wanderings. We have walked these paths through the deepest hours of darkness, discovered secrets in dewdrops and fragrances, witnessed flowers open and close according to rhythms older than human memory. Let us complete our journey by exploring these final wonders, gathering the last gifts the night garden offers before we must return it to the sun's keeping. Our exploration in this final segment begins with one of the most enchanting night bloomers from the tropical world, the Rangoon creeper, Quisqualis indica, a vigorous vine that produces clusters of tubular flowers that change color over their lifespan in a remarkable progression. The flowers emerge white in the evening as they first open, producing an intense, sweet fragrance reminiscent of coconut and jasmine blended together. Throughout the night, the white flowers fulfill their primary function, attracting hawk moths with their color and scent. But as morning approaches and the flowers age, something extraordinary happens. They begin to change color, shifting from white to pink, and finally to deep red over the course of 24 to 48 hours. This color progression serves multiple purposes. It signals to pollinators which flowers are fresh and nectar-rich versus which are already pollinated and offer no reward, and it creates a stunning visual display where a single vine can simultaneously show flowers in 3 different colors. The name Rangoon creeper refers to the plant's growth habit and its origin in Myanmar, though it's now cultivated throughout tropical and subtropical regions. In a moonlit garden, the white first-night flowers glow brilliantly while the pink and red older flowers fade into shadow, creating a natural spotlight effect that guides pollinators to the most productive blooms. The fragrance is powerful enough that a single vine in bloom can perfume an entire garden, and the scent intensifies on warm, humid nights when the air holds moisture that helps carry aromatic molecules. Standing beneath a Rangoon creeper on such a night, surrounded by cascading clusters of white flowers and enveloped in their sweet perfume, creates an experience of almost overwhelming sensory richness, nature at its most generous and abundant. As we move through a section of the garden where herbs and vegetables grow, we discover that even practical, utilitarian plants participate in the night garden's magic. Many herb flowers, which gardeners often remove to encourage leaf growth, are intensely attractive to nocturnal pollinators when allowed to bloom. Basil flowers, small and white or pale purple, produce a scent quite different from the leaves, sweeter, with honey-like notes, and they open most fully in evening hours. Oregano and thyme flowers similarly intensify their aromatic oil production at night, their tiny blooms releasing concentrated versions of the familiar cooking herb scents. Even vegetables participate. Squash and pumpkin flowers, which open in early morning in most varieties, include some species that bloom at night, their large yellow or white flowers attracting moths and beetles. These night-blooming squash varieties are particularly common in tropical regions, where daytime heat might stress both flowers and pollinators. The discovery that even the vegetable garden has nocturnal dimensions reminds us that the division between ornamental and edible, between beautiful and practical, is largely artificial. Every plant, whether grown for food or beauty, participates in the same ecological networks, depends on the same pollinators, responds to the same environmental cues. A truly sustainable garden recognizes these connections, allowing even practical plants their moments of beauty and ensuring that pollinators find resources throughout the garden's entire area, not just in designated ornamental beds. Now let's explore one of the most unusual night-blooming phenomena, the midnight blooming of the night-blooming cereus species Selanicerius whittii, which grows as an epiphyte on trees along Amazonian rivers. This remarkable cactus produces flowers only once a year, and the blooming occurs with astonishing precision at almost exactly midnight. Local people have learned to anticipate these blooming events, which occur during specific seasonal periods, and they gather to witness the flowers opening. The blooms are extraordinary, large, white, and intricately structured, with layers of petals surrounding a complex center. The fragrance is subtle but distinctive, described as fruity with undertones of fermentation, designed to attract the specific bat and moth species that pollinate the plant. What makes the midnight timing so remarkable is its consistency. Plants separated by miles of river will bloom at almost the same hour, suggesting they're responding to some environmental cue that triggers simultaneous flowering. Researchers suspect this synchronization involves some combination of temperature fluctuation, lunar cycles, and the plant's internal biological clock. Witnessing these midnight bloomings along Amazonian rivers, with flowers opening on trees overhanging dark water while night sounds fill the air and the occasional bat swoops past, represents one of nature's most magical spectacles. The precision of the timing, not early evening or pre-dawn, but specifically midnight, suggests millions of years of evolutionary fine-tuning to match the peak activity period of the plant-specific pollinators. It's a reminder that natural selection operates with extraordinary precision, optimizing not just broad categories like night versus day but specific hours within the night when particular conditions and pollinator behaviors align most favorably. As we continue our wandering and pause beside a water lily pond one final time, we observe the very last night blooming water lilies beginning to close as dawn approaches. The flowers, which opened wide throughout the night, now slowly draw their petals inward, protecting their reproductive structures from the coming day's heat and light. This closing process is controlled by the same mechanisms that caused opening, specialized cells at the base of each petal that regulate water pressure, causing movement. But watching the closing is somehow more poignant than watching the opening. There's a sense of completion, of a cycle fulfilled. The flowers that attracted pollinators throughout the night have accomplished their purpose. The moths and beetles have come, fed, and carried pollen from flower to flower. Now the water lilies rest, conserving their energy, and if pollination was successful, they'll begin the slow process of developing seeds while their petals wilt and fall away. The water surface, which throughout the night reflected moonlight and stars, now begins to catch the first subtle hint of coming sunrise, a barely perceptible warming of the darkness, a suggestion of blue where before there was only black. The dew that accumulated on leaves throughout the night reaches its maximum just before dawn, every surface in the garden glistening with moisture. This is the moment of greatest beauty and greatest transition, when night's gifts are displayed in their full glory even as day prepares to reclaim the landscape. Continuing our exploration, we discover one of the most poetic aspects of dawn in the night garden, the final fragrant surge that many night bloomers experience just before closing. As if offering one last invitation, one final opportunity for pollination, these flowers intensify their scent production dramatically in the hour before dawn. Angel's trumpet, tuberose, night-blooming jasmine, all the powerful fragrance producers we've encountered on our wanderings, release their strongest perfumes in these final dark moments. The combined effect in a well-planted moon garden can be almost overwhelming, a symphony of fragrances blending and interweaving to create something greater than any individual scent. This pre-dawn fragrance peak serves a practical purpose. It attracts the last pollinators of the night, those final moths and beetles making their last feeding rounds before seeking shelter from the coming day. But it also creates a sensory experience of profound beauty, a reminder that nature's practical functions and its aesthetic qualities are inseparably intertwined. Standing in a garden during this pre-dawn fragrance surge, you're surrounded by the accumulated perfumes of dozens or hundreds of flowers, each one broadcasting its final invitation into the darkness. The air itself seems thick with scent, almost tangible in its intensity. Your other senses heighten in response. You become more aware of sounds, of the cooling temperature, of the dew-dampened air against your skin. This multisensory immersion creates a state of awareness that transcends ordinary consciousness, a meditative presence that connects you deeply to the natural world and to the present moment. As we venture near the garden's edge where it meets wild or semi-wild areas, we encounter one final remarkable night bloomer, the evening lychnis or white campion, Silene latifolia. This plant, which grows in meadows and along roadsides throughout Europe and now in parts of North America where it has naturalized, produces simple five-petaled white flowers that open in the evening and close by mid-morning. The flowers aren't particularly large or showy, perhaps an inch across, but they're numerous, and their collective impact is substantial. What makes evening lichtness particularly interesting is its specialized relationship with a specific moth species, Adina bicruris, which pollinates the flowers but also lays eggs on them. The moth larvae feed on developing seeds, consuming some but not all of the plant's reproductive output. This relationship represents a different kind of plant-pollinator interaction than we've mostly discussed, one where the pollinator takes payment not just in nectar but in actual seeds, creating a more complex cost-benefit equation for the plant. The plant must produce enough seeds to feed the moth larvae and still have surplus for its own reproduction. Evolution has calibrated this relationship carefully. The moth doesn't consume so many seeds that the plant's reproduction fails, and the plant produces enough extra seeds to afford the loss while still benefiting from reliable pollination. In moonlit meadows where evening lichtness grows abundantly, the sight of thousands of white flowers glowing softly while their specific moth partners visit them represents ecological partnership in one of its most refined forms. Now, as the first birds begin their pre-dawn songs and the eastern sky shows the faintest suggestion of color, let's consider how to create your own moon garden, bringing the magic we've experienced on these wanderings into your own outdoor space. The principles are straightforward but important. Choose plants with white, pale yellow, or silver foliage that will reflect available light. Prioritize species that intensify fragrance at night or bloom exclusively after dark. Arrange plants to create layers of height and texture that will cast interesting shadows in moonlight. Include a seating area where you can comfortably spend time in the garden after sunset. Consider water features to add sound and reflection. Use strategic lighting sparingly, if at all, just enough to illuminate paths for safety while leaving planting areas in natural darkness. Plant in drifts and masses rather than single specimens to create visual impact visible even in low light. Include plants with different blooming seasons to extend the moon garden's period of interest from spring through fall. Think about fragrance distribution. Place intensely fragrant plants near seating areas but not so close they become overwhelming. Most importantly, create your moon garden as a destination, a place specifically designed for nighttime use rather than an afterthought. This might mean positioning it away from security lights and street lights that create light pollution, or using screening plants or structures to block unwanted illumination. The goal is creating a space that honors darkness, that allows you to experience your garden in its nocturnal state without the intrusions of modern artificial lighting. As dawn's approach becomes undeniable, the sky definitely lighter now, stars fading, the moon a pale ghost barely visible, we must acknowledge what our wanderings have revealed. The night garden isn't merely the day garden in darkness, it's a fundamentally different ecosystem operating according to different principles, populated by different communities of creatures, offering different gifts to those patient enough to receive them. We've discovered that flowers time their blooming and fragrance with precision to match pollinator activity. We've learned that dew isn't just condensed moisture but a resource, a visual enhancer, a window into invisible patterns of heat and cold. We've witnessed flowers that live for single nights, investing everything in one brief opportunity at reproduction. We've encountered fragrances powerful enough to travel hundreds of feet, electrical field detection systems that allow flowers to sense approaching pollinators, and color-changing blooms that signal their pollination status through chromatic transformation. We've seen how moonlight affects plant behavior, how different moon phases create different garden experiences, how the interplay of light and shadow transforms familiar spaces into mysterious grottos. We've learned that many common plants have nocturnal secrets, intensified fragrances, subtle movements, changed chemistry, that go unnoticed unless we venture into darkness to observe them. We've discovered that the boundary between day and night isn't a sharp line but a gradual transition, and that some of the garden's most magical moments occur in these liminal spaces: dusk, dawn, the interplay of moonlight and artificial light. But perhaps most importantly, we've learned that the night garden offers something increasingly rare in our modern, illuminated, always connected world: genuine darkness, genuine quiet, genuine stillness. In the night garden, We can escape the constant stimulation of screens and notifications, the bright lights and loud sounds that characterize contemporary life. We can reconnect with rhythms that existed long before electricity, with experiences that our ancestors knew intimately but that we've largely forgotten. The night garden teaches patience. Flowers open on their own schedule, not ours. It teaches attention. The subtle fragrances and dim visual cues require focus to perceive. It teaches humility. We're visitors in a world that functions perfectly well without us, following rules we didn't write and pursuing purposes we can only partially understand. It teaches wonder, the sheer creativity of evolution, the elegant solutions to complex problems, the beauty that emerges from millions of years of mutual adaptation between flowers and their pollinators. As the sun breaks the horizon and golden light begins to flood the garden, the night bloomers close, the nocturnal pollinators retreat to rest, and the dew begins its transformation from liquid to vapor. The garden shifts its character, becoming again the familiar daytime landscape we know. But for those of us who spent these hours wandering in moonlight, the garden will never be quite the same. We know now what happens in darkness. We've witnessed the secret life that unfolds while most people sleep. We understand that the garden is not one place but many, changing with the hours, revealing different aspects of itself to those willing to observe at different times. The night-blooming flowers we've encountered, Queen of the Night, Moonflower, Angel's Trumpet, Evening Primrose, night-blooming water lilies, tuberose, and dozens more, they'll bloom again tomorrow night, and the night after, and the night after that, continuing their ancient conversations with moths and bats and beetles, continuing the reproductive strategies that have sustained them through countless generations. The dew will form again, creating its temporary jewelry across every surface. The fragrances will perfume the darkness. The moonlight will create its silver landscapes of shadow and illumination. These things will happen whether we witness them or not. The night garden doesn't need our appreciation to function. But something in us needs the night garden, needs the reminder that beauty exists beyond human purposes, that patience is rewarded with revelation, that darkness is not emptiness but rather a different kind of fullness, populated by its own communities of life operating according to their own imperatives. As we take our final steps along the dew-dampened path, leaving the garden to its daytime transformation, we carry with us the gifts of our nocturnal wanderings. We've learned to see with different eyes, to smell with greater attention, to listen with enhanced awareness. We've discovered that a garden is not a static display but a dynamic ecosystem changing hour by hour, season by season, year by year. We found that some of life's deepest beauties reveal themselves only to those willing to wait, to watch, to venture into darkness with open senses and patient hearts. The moonlit garden will be here again tonight, and tomorrow night, and for as many nights as we choose to return. It asks nothing of us except presence, attention, and respect. It offers in return experiences of beauty, wonder, and connection that no artificial entertainment can match. It reminds us that we are part of nature, not separate from it, and that the rhythms of darkness and light, growth and rest, blooming and fading are rhythms we share with every living thing. As the last stars fade from the brightening sky and the nocturnal garden yields fully to day, we complete our wanderings grateful for what we've witnessed, enriched by what we've learned, and already anticipating our return to this magical realm where flowers bloom in darkness, dewdrops catch moonlight like diamonds, and fragrances perfume the night air with invisible beauty. The garden continues, patient and persistent, blooming and growing, collecting and releasing, in rhythms as old as life itself, as constant as the moon's phases, as reliable as the turning of the earth from darkness into light and back again. Until we meet again in moonlight, may your own gardens, whether physical spaces or gardens of the mind and spirit, bloom abundantly, both in sunshine and in shadow, both in the bright hours of activity and the quiet hours of rest. For we have learned, through our wanderings, that both are necessary, Both are beautiful, and both contribute to the full expression of life's endless creativity and wonder.